Good evening, everyone. Thank you for being here for this mining session organized by Geology and Sustainable Mining Institute. So in this session, we are going to talk about the mining of the future. As you know, mining plays a vital role in our life in providing metals for industry, for infrastructure. However, the constraints of mining of yesterday are not the same of today, and they will not be the same for tomorrow. So during the session, we are going to talk about the emergent and constraints and challenges of mining. So we have prepared a diversified and exciting presentation for you. So we'll start with three presentations. The first one will be about how the mine of the future will look like. The second one about carbon neutrality in mining. And the last one about the mining 5.0. Please note your question. We want this session as a discussion session. We want your question for our presenter. And then if you still have questions, we'll have a panel session that will start at 5 p.m. Where we are going to discuss with our presenter and other industry people that we are invited today. So I will invite Dr. Richard Lilly for the first presentation. So Dr. Richard Lilly has 25 years exploration, geosciences experience, spanning the industry-academia boundary. After completing his PhD at Cardiff University in UK, he moved to Australia and worked for Mount Isa Mines exploring for copper and gold in the far north Queensland between 2007 and 2015. In 2015, he began a role as an embedded research fellow at the University of Adelaide, where he coordinated and supervised over 70 applied research project related to ore deposit and advancing ore body knowledge. He co-founded the National Exploration Undercover School called Nexus Program in 2016 and was named South Australian STEM Educator of the Year in 2022. Dr. Richard, thank you for the long flight, 33 hours flight from Australia, and we have the pleasure to host you at UM6P. Thank you so much.
Thank you everyone for coming to this session, and it's my pleasure to be here in Morocco. I'm enjoying my time here very much at this fantastic university. My talk is on the mine of the future, and I'm a geologist, so I like rocks. I've always enjoyed rocks and studying them, and in the UK, growing up, if you study rocks, everyone just thinks you like dinosaurs or volcanoes. But I've always enjoyed shiny rocks, and many of the rocks in Australia contain gold, copper, and all of the minerals that you need, so that really got me into mining, and I'm very pleased to have moved to Australia with my family. The mine of the future. When I was asked to talk about this is a very big topic, because there's many things that we mine, there's many methods that we use for mining. So I wanted to break the talk into some sections. Why do we mine? What do we mine? Where do we mine? How we mine, and probably most important is who is doing the mining. And this is important for you all in the audience, because in the future this could be you doing the mining. So the question to start, why do we mine? Well, we mine because we are human. Humans have always mined. In fact, this oldest stone tool in the world from Lake Turkana in Kenya is 3.3 million years old. This is older than Homo sapien. Modern humans have only been around for 300,000 years, and humans have always used tools. The oldest mine is in Africa, in Swaziland, mining hematite ochre for paint for the face or for ceremony. And the oldest metal tool was found in the Middle East around 7,000 years. So we've been using minerals and metals for the whole of our existence. However, now in our modern lives, we're mining so many things. These images show our house and the elements that are used in the house. We have steel in the house, made of iron, maybe some manganese, maybe some vanadium. We have copper in the pipes. We have zinc maybe in the paint. Hopefully you all brushed your teeth this morning, and if you brushed your teeth this morning, you would have used titanium. Titanium is what makes the toothpaste white. titanium oxide. We mine that a lot in Australia. If you have a phone, I'm sure everyone has a phone. These have many, many elements, and we need to mine all of these elements. And into the future, the internet, driverless vehicles, carbon capture, water management, all of the problems that we're facing and all of the challenges we are addressing in our modern lives need elements, we need minerals, we need materials. And unless it is grown from the ground, it needs to be mined. So mining is very, very important for all of the challenges that we face. This statistic is something that I found very breathtaking when I first saw it. The volume of human-made materials on the planet now exceeds the volume of biomass. So the amount of material generated by humans is now more than all of the trees, all of the plants, all of the fish, all of the animals. And most of that is things like concrete and gravel and sand. So we are being very, very busy humans, and we have exceeded the amount of biomass. And this is because we have been mining. And our demand for minerals, our demand for materials is speeding up. This is a statistic I remember from a few years ago. Between 1900 and 2000, the United States of America used 4.5 billion tons of cement. When I think of the USA, I think of McDonald's and highways and shopping malls. And that took, in 100 years, 4.5 billion tons of cement. In 3 years, between 2010 and 2013 in China, they used 6.6 billion tons. So the amount of materials using is incredible. Can I ask you a question? What do you think is the most mined commodity in the world? What do you think we use the most as humans that we mine? Please shout out if you know. Iron? Good suggestion. It's not iron. Copper? No. Sand. Sand is the most mined commodity. We used 50 billion tons every year. And that is enough, which is crazy, 18 kilograms per person per day for the whole planet. Every human has 18 tons of sand per day. There's actually a problem in Australia finding enough sand. We may have sand in the deserts, but it's the wrong kind of sand. It's too round. You need slightly angular sand for building. So sand is a big commodity. I used to use this image to illustrate the growth in China. This is a picture of Shanghai in China in 1987, and this is the same view from 2013. I started using this slide in 2015, so it's already 10 years old. And some of you might see the flying car. I put that on there. That's not real. But I put it on there because Shanghai, if there's ever going to be a city with flying cars, it will probably be Shanghai. But as you can see, the growth in this particular part of the city is amazing. And I look at that and I think, what about the resources for the buildings? The iron, the sand, the concrete, the glass, the elevators, the screens. But this is in one corner of one city in China. And of course, it's Africa's turn next. And actually, you don't need me to tell you about development in a fast period of time. The resources that would have built this wonderful university have happened in a very short time. So we are doing a lot of mining. All of this material would have been mined. And it's a fantastic university. I'm very pleased to be here. So we also talk about the shift towards global renewable energy, electrification. These are big topics around the world, solar panels, wind turbines. But of course, you need to mine resources to build these items. And when I teach in Australia and I teach my students, every single graph that I show them goes up. The first graph is the amount of wind power around the world, going up every year. This graph is the amount of lithium. Lithium is used in batteries. Your phones will have lithium in from Australia. We're one of the biggest producers of lithium in the world. That goes up every year. The other one is battery demand for storage, maybe for your Tesla. Every graph for resources goes up, whether it's iron, copper, lithium, wind power, mobile phones, everything goes up. And this is because our population is growing faster than at any time in history. And our mineral consumption, our demand for minerals is exceeding that. It is going even faster. And we need to mine these materials. So what do we mine? What materials do we mine? Well, every year with our demand and our technology, we are using more and more elements. 300 years ago, people would use coal, maybe some iron, maybe some wood, maybe some lime, sand. Then we have our first industrial revolution where we start using more metals, copper, zinc, lead. Then automation and automated production, the second industrial revolution. And of course now in the 2000s we're into the fourth industrial revolution and the fifth. And every year that list of elements becomes longer. Elements that you may not even see yourself on the periodic table. There's so many, but we need them now, and we need all of them. And this is an example as well. You know, not only are our industries changing, but the population is increasing, and we need more and more material. I like this example. My father had a phone like the one on the left, a brick, we used to call it. And a phone in 1995 used to use around 30 elements. A phone today uses around 75. A lot of those are in the screen, the colors, the beautiful colors in the screen. They're used by what we call rare earth elements. Now, we had no way of predicting that mobile phones would become so popular. And we had no idea that we would need these additional elements. So the question is, what elements might we need in 20 years' time? What will the next gadget, what will the next product be? And what elements will we need? And how will we source them? Where will we find them? These are huge questions that we deal with in geology and mining and in any form of sustainability. So we know that all of our demand for materials is increasing with energy. And we know that clean energy will very soon become more popular than coal, oil, gas, and hopefully things like hydrogen will become part of the story as well in a big way. And it's not far away. Very much in your lifetimes, we'll be using much more clean energy, but we need to build the material, and we need to mine material. So unfortunately, we can't just build these with existing materials. We can recycle, but that's not enough. We need more. So global renewable energy will require more resources than ever before. Cars. When, even a few years ago, seeing a Tesla in Australia was quite unusual. Now we have 2 on my street. And they're very cool. They're nice cars. But they contain many materials. They contain copper, lithium, manganese, nickel, cobalt. And the number of cars, again, on this graph, everything goes up. That's all you need to remember. Everything goes up. And the global number of electric cars is predicted to increase by at least 10 times in the next 5 years. In places like Sweden and Norway, you cannot buy an internal combustion engine car anymore. They're banned. So you have to buy an EV. Hopefully they become cheaper. So these are some of the elements involved in an electric car. So we have things like copper, lithium, manganese, cobalt, nickel, and rare earth elements. And we'll just look at copper and rare earth elements for a few moments. You know, the main use of copper, it's a very beautiful metal, and it's a very useful metal. We've been using it for a very long time. The main use of copper is in pipe and wire. So I have some questions for you again. How much copper do you think is in a mobile phone? You can shout out the answer, please. It may be in grams. How many grams of copper in a mobile phone? 30? More? Less? 10? Anyone else? 100? That may be my dad's phone. About 6. In a new iPhone 16 Pro Max, about 6 grams. Older phones, maybe 15 to 20 grams. How much in a Dacia car? Normal car? In kilograms. Anyone? 5? Any advance on 5? More? Less? 20? More? Less? Don't be shy. Let's go. 15. 20 to 25 in a normal car, petrol car, gas car. How much in a hybrid car? Sorry? 7? 20? 30? 100? There's quite a lot of variation. That's good. I like it. 40 to 60 in a hybrid. How much in a Tesla? 200? 100? 80? Let's see. You're close, yeah, 80 to 100 kilos. You know, Tesla cars in Australia, they have, you know, car parks and car parks, multi-story car parks we have in Australia. They have to redesign multi-story car parks because these cars weigh 3 times as much as a normal car and the building would collapse, so they have to redesign them. Okay, we have just 4 more. How much copper in a house? A normal suburban house? In pipes and wire? 500 kilos? Any more? Any less? 200? Yeah, I used to think about 200. These days they're getting more efficient with the wire, about 100. How much in a Boeing 737 that brought me from Casablanca? 2 tons? Any more? 500 kilos? Any more? Over here? 800? Close. About 4 tons. 4,000 kilos of copper. Just copper. Just copper in a plane. How much in a high-speed train? Like a teacher there. 20 tons? Any more from 20? 10,000 tons. That's too much. No. In a train, approximately 7.5 tons. Oh, it's okay. And how much in a wind turbine? An environmentally friendly, green energy wind turbine. 9,000, so 9 ton? 10 tons? Up to 30 tons. The older ones maybe. These newer ones maybe just 4 tons. But up to 30 tons of copper in a wind turbine. So wind turbines are fantastic, but we still need to mine the material to build a wind turbine. So we use a lot of copper. My speciality in geology is probably copper deposits, so that will keep me in a job, hopefully. So we use a lot of copper. In fact, we use so much copper. On this graph, we have the orange line is the demand for copper. The green at the bottom is the copper that we know we have in deposits, and the red and the pale color are maybe projects that we can start. So we're actually facing a problem now that we actually cannot produce enough copper to meet the demand. So the price will go up. We have used a lot of copper in the last 20 years, but the statistic as well that is crazy. During the next 25 years, we'll have to double the amount of copper we've ever mined as humans. We've mined about 700 million tons of copper, and we need another 1.4 billion tons of copper. So is this sustainable? And this is just copper, not cobalt, not nickel, not all the other metals. So we are mining an awful lot of material, and we need to mine this to meet our demand or meet our needs. We'll talk quickly about rare earth elements. These are the ones at the bottom of the periodic table that have all of the complicated names that are hard to remember. I still can't remember all of them. It's these bottom ones. In the last 10 years, we've seen a huge surge of demand. These elements are very useful for mobile phones. Particularly, they're very good at making making magnets. You know those very strong magnets? This is what these are for, neodymium magnets particularly. Wind turbines use a lot of magnets. So each wind turbine has about 500 kilograms of rare earth elements. A fighter aircraft has 0.5 ton of elements. A submarine has 5 tons of elements. So when we start talking about these equipments for safety and defense, and we need rare earth elements, suddenly this means that our supply chain for these elements is heavily politicized. It is very much politics. Who has these elements? And interesting, well, we will talk about that in a moment. But global metal use is increasing. This chart is showing the use of all of the different metals from chrome, gold, lithium, tin, tungsten. All of the metals are going up in terms of our use. There's only one you can see at the bottom. One is coming down, and that's arsenic, which is good because arsenic is poisonous. We don't want arsenic. Arsenic we don't need to use it. But demand for all of the metals is increasing. All metals are now critical. We call them critical metals. Where will we source these metals from? Where will you source these metals from? So where will we mine? There are many diagrams that show which countries have different combinations of elements. The wheels on here show the relative amount of each element. Morocco is on here, of course, for the phosphorus. Morocco is the world's leading source of phosphorus, very important for food, very important globally. But you can see the biggest disk is China. China has by far the most amount of rare earth elements. And of course, this is also unfortunate because the United States of America do not have very many rare earth elements. So access to critical minerals is strategic. China controls most of the rare earth element production, and it's a huge opportunity. You see, there is not many disks in Africa. Africa is very underexplored. There's huge potential for mineral deposits in Africa, so huge potential for exploration and mining in the future. We've only scratched the surface. I think only maybe 1/3 of Africa has been properly mapped. So we have a lot of opportunity. Australia, we have plenty of things, but the geopolitics of resources will only increase, which is a shame for me because I just like rocks. I don't like politics. I prefer rocks, easier. Australia is benefiting from this critical metals gold rush. You can see the bars on this chart. The one on the left is Australia. This is showing how much of these materials we have, and Australia is doing very well. Interestingly, the United States is over on the far side on the right. They haven't been investing in their materials for a long time, so their mining industry is actually going down. And the importance of mining to Australia is it employs over 300,000 people directly, and it contributes nearly $500 billion to our economy. So mining is a very good source of money for the economy in Australia, so it's something that has seen a great deal of investment. In fact, there are many brochures and materials coming out now which help us to envisage what we can do to try and encourage businesses to invest more money in mining. Many people, there is a big disconnect. They want a mobile phone, they don't really want to mine the materials. So mining in Australia is becoming less popular. Now, I'll draw your attention, though, to this top statistic. This says that because of the demand for batteries and other materials, we will need 140 new copper mines. Many of the copper mines that we have today are getting old, maybe past peak production, and we will need 140 new ones. Where do we find 140 mines? It takes a long time. If you're very lucky and you work in exploration, you might be involved in a discovery. And then it might take 10 or 15 years to go from a discovery to a mine. But we need this copper for our Teslas today. We need new phones tomorrow. Where are we going to get this? And that's just copper. We need 60 more nickel mines, 50 more lithium mines. So this was the mine that I used to work at. It's a copper lead zinc mine, and they're closing their copper mine this year, in a few months. They've used up most of the best ore, so it's actually it's going to just go to being a zinc mine. So many of the largest mines in the world have gone past what we call peak production. Their production is coming down, and some are closing. So where will the new mines be? And how will you find them? You'll have to find them if you need the materials. I'm getting too old, so you guys have to do it for us. Most of the mines of the future will be ore deposits that we haven't discovered yet. And that's quite a profound thought, really, that in 20 years we'll be mining deposits we haven't found yet, and we need to find more. So effective mineral exploration and training of geologists and geoscientists is crucial to meeting this future demand. It's not just about having the metal, it's about having the skilled people to find it. I don't think AI is quite there yet to be able to discover mines. The patterns are too complicated. So how will we mine? There are many methods of mining. People have a stereotype of mining that it's quite old-fashioned. But mining is always in change and embrace technology. The oldest mine in Australia is in WA, Western Australia. It's around 30 to 40,000 years old. It's an ochre mine on Wajari country in WA. And it was hematite ochre for the body paint. South Australia, where I live, had a lot of mining in the 1850s, 1900s, traditional mining. When you think of mining, many people think of black and white photos, underground, people with a pick. But that was the new technology at the time. That had steam. That had steam pumps. That was very new technology. And mining today in South Australia at somewhere like Olympic Dam, which is one of the world's largest deposits, embraces all of the new technology. So mining, even though people think it is quite old-fashioned, really does embrace a lot of the newest technologies around. Last night when I was finishing my presentation, I just put into Google miner, and this is what comes up. Generally men, generally dirty, generally with a pick or a lamp. But actually the modern miner is just as likely to be working in front of a computer. Many of my friends in Australia who work for the mines, they work from home. So the technology that's increasing in our systems is actually making it much less likely that you're going to be underground so much. I think in the future, we'll look at pictures and say, we actually used to go underground ourselves and we didn't send the robots. You know, so I'm sure that automation will bring some advantages as well. So I'm not going to talk too much about the future technology of mining because I think one of our speakers will talk about that. However, this slide does summarize a few of the technologies that are very much on the increase for future mining. So alternative fuel and renewable power. Many mines in Australia now are using wind power and solar power to power them rather than traditionally diesel. Automation. In Australia, we have many automated mine trucks. One operator at a computer center can operate several trucks at one time, and most of them will just be automated. There are many sensors which can sense whether the ore is good grade or not so good grade, and ventilation, pumping air into the mine. If you can ventilate on demand, it saves a lot of power. Then we use GPS, satellite technology, and drones. Drones are becoming very popular for surveying. You can fly around the mine and take LiDAR. It's excellent, becoming very normal now that most mines will have a drone team. 3D printing of equipment. If something breaks down and you need the spare part, you can just print it yourself. You don't need to wait to have it flown from somewhere else in the world. 3D imaging and data optimization. Again, all the computing power that we have is being used for mining to help design and plan and action the mining. Equipment management as well can be done through active data. Wearables. So actually some of the mines when you go underground are very, very hot, can be up to 60 degrees in some of the mines in Australia. They're actually designing suits, almost like a spacesuit, that will keep the operator cool, keep them safe, give them air supply. And of course vehicles, battery vehicles or electric vehicles, replacing diesel. Running a diesel engine underground in a mine produces a lot of fumes that you then have to ventilate. So there's a huge number of advances, and mining in Australia in particular and around the world is embracing all of these, and we'll hear more about that later, I'm sure. So different mining styles as well. We're all familiar with open pit mining, just digging a big hole. I think phosphorus mining is probably quite straightforward on the surface, big bulldozers. But actually, sometimes if your ore deposit is quite deep, in South Australia we have many deposits that are buried. The ore doesn't start until maybe 1 kilometre down or 500 metres. How do we mine efficiently on a large scale when we have a buried deposit? And Carapatina is a deposit that I've worked on for many years. It's a copper gold deposit, it's very big. And they're using something called block caving. So this is the rocks. I had to put one photograph of a rock in. A lot of the red is iron, so it's an iron oxide copper gold deposit, and it's quite steep. It's almost like a volcano. It's like a pipe. And to mine that effectively, they're doing something called sub-level caving and block caving, where they develop and they blast, and all the material falls down into an underground collection. So this is sort of the modern way of mining. And the mining level that they're mining at is 1,500 meters, so 1.5 kilometers underground. It's very deep. Another form of mining that is actually probably as important in the future as anything is what we call in situ recovery. This is something that's being trialed in South Australia, and it has many, many advantages, probably not on a very large scale, but is a particularly useful style. You can see in this image the water is kind of green, and that's because it's got copper in it. This is a place called Kapunda. Kapunda was a historical mine discovered in the 1840s and mined because people found malachite and azurite and the colourful copper oxides on the surface, and then it was mined for maybe 30 or 40 years, and then it finished. There wasn't enough good ore, and the mine just sat there. Although you can still go there today. There's my friend Jenna, and you can find malachite and beautiful minerals. And when it rains, the pit, this is the historic pit. Now it's a tourist attraction. People will come for many miles to see this blue water, but the blue water is full of copper, up to 3,000 ppm copper. And what the company is doing is they're using what we call in situ recovery. And it's very simple, really. In situ recovery is a technique that was used by the oil and gas. You drill down to the layer that you want, and then you maybe use a little bit of weak acid to help the rocks break up a little bit, and then you just suck out the fluid. So they're simply they're sucking out that copper-rich fluid, and then they use a particular technique to extract the copper. Now this is really good, and this map here is a resistivity image which shows where the less resistive ground is, so that's basically where the copper is. And they've done many careful monitorings to make sure that the groundwater hasn't been disturbed and that the impact on the environment there is not so great. They've done very good work, and it's been very carefully done. And that's what the mine looks like. That is their current mine. They'll be starting mining later this year. And all it is, you can see the two well bores there. They just suck the copper out, they pump the copper fluid out, and then they pump the water back in. And this is in the corner of a field, and the farmer can still have his sheep in the other part of the field, and when they've used up here, they'll move it maybe 100 meters, do it again, and continue. And you might think, well, yeah, okay, that's a small program. And it is relatively small compared to many of the operations in Australia, but this technology has worldwide application. I'm sure in Morocco there are historical copper mines with similar features. And there's a little bit of this happening in America, but South Australia is actually the main thing. And you might think that's maybe not so much money, but this little deposit here has 47 million tons of 0.25 copper. So they expect to have 119,000 tons of copper. And that's actually worth 1.2 billion US dollars, just from this place, just from the water that's already there. There's no mining, they just pump it up. And if you can apply this to many places around the world, then not only will the people who own the mine make some money, but it's also good for the environment in terms of mining, no more disturbance. So in situ recovery, ISR, is a growth industry and has huge potential. Yes, I think it's pretty crazy, a lot of money. And we must also talk about mining waste. When we mine something, most of what we mine is thrown away onto the waste pile. And with the increasing amount of mining that we have to do, the amount of waste will increase a great deal. Again, all of the charts go up, but in this particular case, the chart on the left is showing copper production, and the lines coming down show the average grade. So we're mining more, but the average grade is coming down, and that means that the amount of waste will just keep increasing. So the volume of waste is going to go up an awful lot. We're going to get covered in waste if we're not careful. And it's a problem because we need to put this somewhere, and it costs money to move, and it costs, environmental impact by the energy used to move it. So what do we do with all this waste? The key point is going to be a circular economy. Future mines must embrace. Essentially, this means in mining to minimize what you're mining, to make the most use of it, and to try and find value from as many products of your mine as you possibly can. This is a huge part now, really, to doing it. There are mines in Australia where they have to mine through some clay to get to their ore, and actually now they're making tiles from that clay and selling those. So any product that you move, any product that you're mining, to be able to use it is very important now. And it's your innovation is key. Traditionally, this stuff was just thrown away or made onto a pile. It's only now that we're actually starting to see there may be value. And it's the opportunity of your innovation that I think will be key to solving some of these problems. Some examples of how we deal with mine waste in Australia would be, well, we're recovering copper from Kapunda. One of the waste products of a particular kind of mining is mica, and that's what they put in cosmetics to make it shiny. So there are cosmetics companies actually using reclaimed mica from waste dumps. They're using particular waste for building materials, using a particular kind of process to compact it into bricks that can be used to build other infrastructure on your mine site. And in a few years, there'll be the Olympics in Brisbane, and they're hoping to be able to, or there is talk of maybe trying to recover the gold for the medals from old mines. So it's lots of opportunities. Australia at the moment is spending a lot of money on cataloguing and using valorization on their mine waste. This is an example of one of the projects. There are many scientists working to go to all of these old mines, and they are cataloguing and analyzing the waste to see how much material we have. Lots of very boring reports, I have to say, but you know, they're being done. But what is important though is it's giving people a chance to actually go and look at this waste, see what it is, actually revisit what potential opportunities there is with this waste. And some of my friends have been working on this and they've been enjoying it a lot. So we're doing a lot of sampling, just categorizing, finding out what's actually there, because in the past no one cared. They mined it, what they didn't want they threw away, and they just left it there. Maybe there's gold, maybe there's value, maybe there's rare earth elements that we never knew we had in the waste, and until we look, we don't know. And it also gives the opportunity to do good science using SEM, EDS and different hyperspectral techniques. We can actually characterize that material and make it more approachable for some form of metallurgical process afterwards. So we're generating a lot of data in Australia on this kind of thing. Waste is a huge opportunity, and actually any of the geologists in the room should recognize what that mineral is. That's pyrite, what we call fool's gold, and most of the value in waste is actually coming from that mineral because it holds, it's like a sponge, it holds a lot of different elements, rare earth element, well, not so much rare earth, but cobalt and nickel and other elements are often tied up in the pyrite. So it's quite useful, but we didn't want it before. But how do we recover the metal? I mean, it's all very well to have, we know that we have this metal, but how do we get it out? And that's where we are. There's a huge opportunity. So if there's anyone in here who does chemical engineering or metallurgy, the opportunity for innovation in minerals processing is wide open. Because we're really not very effective at that at the moment. In fact, all of these studies that they're doing in Australia on mine waste, there's only one group that I know of who are actually looking at ways to get the copper out effectively. And this is a group in the University of South Australia. It's a technique called resin in moist mix, and it uses a special kind of polymer. You crush the waste rock, you put it in some weak acid, mix it with the polymer, and then you get this blue liquid out once you filter it, and that's copper sulfate. And that means that you can just extract copper quite easily. So that's an exciting technique that hopefully we'll get some more examples of in the future. But now we come on to the last topic, but also probably the most important for me: who will mine? And here's my friend Cam, she originally from Mauritius. She moved to Australia to do her PhD. Then she has now working in mine waste, and she did the program with Nexus with me. And she's a great example of who we need mining. You know, how do we attract the next generation of talent into the mining and exploration industry? In Australia, working in the mines pays very good money, but we're actually struggling to bring people in. As an industry, we're struggling to retain talent. And again, partly that is because of these stereotypes of mining. People may not want to be involved. They don't see the modern aspect of mining that we're exposed to so much more now. They do surveys every year in Australia and ask youth. This survey is from people from the age of around 15 to 21, asking them, when you hear the word mining, what do you think of? And these are the words that come out. In Australia, we mine a lot of coal, and of course coal is not great. We'd love to move away from that, but it's always the same. I do this every year with my students, and it always looks the same. Money, gold, hard, minerals, underground, dirt. This is what people think of when they think of mining. It's just how it is. But we need to change that, because the industry and education landscape is changing. It's evolving quite quickly. Particularly, I'm a geologist, so I'll talk about geoscience, but this is equally applied to engineering. You know, we have had traditional geoscience education you have at university, but we also have challenges. In Australia, we have the Uncover Challenge, looking for deposits underneath sand dunes and underneath, you know, that aren't outcropping. Industry 5.0, it's changing everything. Big data, data analytics, disruptive ideas, new technologies. In Australia, universities are very slow to adapt. So actually, a lot of the traditional geoscience education is not including many of these things. So when people start work, they're like, oh, what's all this? You know, it's a surprise to them. Community acceptance. Many communities don't want mines on their land. They don't want mines near their agricultural land. Partnerships with traditional owners. In Australia, it's very important now to have good relationships with the Aboriginal people who are custodians of the land. It's the same in many parts of the world. There are many places where traditional owners would rather there not be mining. And a diversity of people. We need to encourage all people to be involved in mining. And a very important one for the companies is to retain talent. Given that the number of people coming into mining is becoming smaller, we need to retain the people who are there. And I see it with many of my ex-students, they're moving jobs all the time if they're not happy with their company. So if companies have good employees, they need to retain them somehow. And that's becoming a big issue. So just briefly, 17 universities in Australia offer geoscience. And when I first gave this talk 3 years ago, we had 19. So we've lost 2 departments teaching geology in Australia. Geology is actually becoming not such a popular degree, which is a shame. The boom and bust, we talk about this in Australia. When the metal prices are high, everyone wants to work. When the metal prices come down, maybe there aren't so many jobs. So this kind of does dominate enrollments. And it's not just an Australian problem, it's the same in Europe, it's the same in America. I'm not so sure about Africa. So I would like to think that it's, it seems to be happening everywhere. And again, it's not just geoscience, it's engineering, chemical engineering, any STEM subject, biology, chemistry, physics, all of them in Australia are coming down. The chart here shows, the chart here shows in the blue line we have the number of students. So you can see it's peaked maybe 10 or 15 years ago and it's been coming down. The red line is how much money companies are spending on exploration. So you can see there's a bit of a lag. And the lower chart is the number of students in the classes that I teach. Hopefully it's not because I'm a terrible teacher, but it's just showing that the students' numbers are just generally coming down. So geoscience is in trouble in Australia and I think around the world. So we need more geologists. If you like rocks, please become a geologist. It's awesome. So that's what we've been doing in Australia lately with the process of what's happening with geology. We're a little bit stressed. So where are the students going to come from? Well, kids don't know about geoscience. In Australia, there's no geology taught at schools. It gets lost in with other aspects. Most people who learn a little bit of geology quite like it. And there's a huge disconnect. I can't understand why, but there's a huge disconnect between stuff, our phones, our cars, our Teslas, and the fact that we've had to mine the material to get it. So I'm not quite sure why that is. And many young people don't know what career they'd like to do, and that's understandable. I didn't know what I wanted to do until later on, and mining lacks personal relevance for a lot of people, and very few students are set on a single career choice, and that's good because you have so many opportunities ahead of you. So I get asked all the time, what skills will geoscientists of the future require? Should we be teaching people to fly drones? Should we be teaching people 3D modeling? Should we be teaching people about automation and programming? And yeah, we should be doing all of that. But actually the most important thing is they need to be good geoscientists, I think. These days getting a bit more coding is obviously very valuable for everyone in every profession these days. But you need to be good at your core subject to start with, and you can learn many of the other things on the job. So the opportunities for training need to keep coming and keep up with the industry. I feel the gap between what people are learning at university and what industry wants people to know is maybe broadening a little bit in Australia. And this quote by Brendan from Rio Tinto saying that mining companies are increasing their grad intake but reducing traditional disciplines. It means that I have a friend who's a mathematician. He did maths and he did a little bit on geology, and he now works as a geologist because they wanted someone with the math skills. So any profession can really diversify into mining if you wanted. And this is something I show my students too. This is what we call the T-shaped worker. So if you're a geologist or an engineer, you want the vertical bar to be your skills, your exploration or mining specific skills that you learn at university. But these ones across the top, they're called enterprise skills, sometimes called soft skills. These are problem solving, teamwork, critical thinking, creativity. These are things you don't necessarily get taught at university, but these are actually probably the most important because these are the ones that you can transfer between jobs. So if you're going from being one career to another, you may not use the geoscience in the next one, but you will use these ones at the top, and these are very important to keep. So for the students here from UM6P, when you're studying your PhD, you're learning a lot of these during your PhD. Your PhD will be obviously learning the technical skill, but you have all of these other ones which are picking up along the way. And these are very highly valued by employers. So in fact, those are the ones that are mainly tested in interviews. And this statistic in the box here says that Gen Zs are expected to have 18 employers and 6 careers. So, the olden days when you had a job for 20 or 30 years and then retired and they gave you a clock or something. That's not the case anymore. So these transferable skills are very important, and hopefully we can keep some of you working in mining and exploration while we do that. And I quite like this map. It's one of my favourites. Someone showed that you know what this map is. It's the map of the London Underground, the underground system in London. And this is sometimes used as a modern career map. It's showing that you can start anywhere and finish anywhere. So it sort of shows that you don't need, career paths are not set. You can go from one to the other, taking the opportunities, changing tracks, changing trains when you feel the need, when it's right for you, when the opportunities come up. And again, now that Gen Zs are expected to have 18 employers and 6 careers, this is more relevant than ever. So not linear. So I'm worried I'm going to run over now, but I'm going to carry on. But how can we best prepare the people for industry? And this is where I get to talk briefly about the Nexus program, which is the program I started with a colleague 10 years ago. It's called the National Exploration Undercover School. The aim was to try and fill the gap between what you learn at university and what industry wants you to know. Founded in 2016, it's a collaboration between universities, government and industry, and students from all over Australia can apply. We normally get around 100 applications, and then we select 35 or 40 people, and we bring them to Adelaide, and we spend 2 weeks doing some really good fun things, or things that geologists think are fun. The reason we do this is, in Australia, many of our ore deposits are undercover, and we were not being taught at university how to effectively find them. And the gap between the red line, which is how much money we're spending on exploration, and the blue bars, which is what we were discovering, was becoming very large. So in 2016, the Uncover initiative was very big. Not so much now, but it allowed us to kick this off. We've had over 400 participants with Nexus over the last 10 years, with a great mix of people. It's a mix of workshops and practical instruction, and based around a range of themes of topics that you might not get at university: advanced ore deposits, geophysics, remote sensing data, GIS, things like that. We do networking, engagement with industry. We've had, very lucky, we've had a great deal of support from the industry in Australia, and many, many people have taken part in the program over the years. And really the key thing is that I find we have a group of people, we bring people who are keen on geoscience together, and we spend 2 weeks doing a lot of fun stuff and looking at a lot of rocks, and they've become very good friends. So it's been a very popular program. I'm very proud of it. We also run a range of online workshops, which we'll be doing as well later in the year. So do connect on LinkedIn, and you'll find out about what workshops we're going to be doing. So I guess to sort of finalize, who is going to be mining in the future? And it's going to be you. You're going to be doing it. I'll be retired, drinking tea. So, it's really up to you. And in terms of, why, what, where, how, and who mines, we urgently need to inspire and upskill the next generation of exploration and mining professionals to meet the growing demand for critical metals. And really, the mine of the future will look like you want it to look. It's up to you how it looks. So on that, I'll leave you with that, and thank you very much.
Thank you, Richard, for your nice and exciting presentation. Maybe we have time for 1 or 2 questions, please.
Raise the mic.
Yes. Okay, thanks for the great talk. I want to ask, what's the role of recycling? How many new mines can we replace by suitable recycling?
I think the opportunity for recycling is very good, but as I mentioned with copper, and it's not just recycling what we have, it's the number of new people that will require items. So I'm sure we can replace a number of mines. I don't have the numbers, but recycling hasn't really been looked into in a serious way for a long time, actually. Even physically, just the number of new mobile phones on the market every year is expounding. So I'm afraid I can't answer, but there's another opportunity there for more efficient recycling and actually getting all of our parents to get all of the old technology out of the cupboard and things, yeah. So there's a huge potential for that, but I don't have the numbers, I'm afraid. Thanks.
So first of all, I want to thank you for this presentation that was for formation. My question is, since you mentioned before that the population is increasing at a really high rate, can we find another way to replace mining so we can fulfill all the requirements and needs of the population?
Thank you, that's an excellent question. Yet I think it would be wonderful if we didn't need to mine so much, if we could find ways around. Like I mentioned with copper, the main use of copper is in pipes and in wire. There must be ways to innovate something that is more sustainable to use for wire or for pipes. I think, yeah, it's a very good question, and it's you know, it's the opportunity of your generation to be able to. Realistically, there's no way we can find that much copper, so we have to do something. And so, yeah, the innovation is the opportunity. So, yeah. Hopefully you can solve it for us. Thank you.
So, thank you so much, Richard. And if you still have, some questions, just please keep them either for the break or during the panel session that will start at 5 p.m. So now I will move to our next guest, who is Tawfiq Tajer, who is going to talk about carbon neutrality in mining. So Tawfiq Tajer has over 30 years experience in the energy sector and currently serves as strategy advisor for technology project at Repsol Spain, which is Spain's leading energy company. Throughout his career, he has led various technical and managerial roles in oil and gas industry, either in Europe and United States, including subsurface manager for Repsol Gulf of Mexico assets and senior geologist at Saudi Arabia Aramco. Additionally, he has founded and managed several startups, for example, GoCAD. Dr. Tajer has a PhD in computer science as well as master's degree in geosciences and business administration. So the floor is yours, Dr. Tawfiq. Thank you so much.
Thank you very much for the introduction. Thanks for the invitation. Believe it or not, it's only the second time I'm making a presentation in Morocco. I left Morocco 30 years ago. I did a lot of presentations, hundreds, but it's the second time. And the last time I was here 2 weeks ago, talking with Dr. Abdul Latif, he asked me if we really, there is an opportunity to share some of the knowledge and with the community here in Morocco as part of all those events, those great events of UM6P, which is, by the way, I'm amazed and amazed by seeing all those activities and those events. With the goal is to shape in the future, and through innovation, through knowledge sharing, through bringing talents, to helping to grow in talents. And I can see here a lot of young generations that will definitely be helping Morocco, Africa, but the whole world, and addressing one of the biggest challenges we are having right now, energy transition. How can we face, how can really contribute to reach this target of carbon neutrality? And mining industry is critical. It's important, it's here for years, it's here for hundreds of years. So if there is something to do for the carbon neutrality, mining will be part of it. Just a disclaimer, and this is really important to mention, kind of housekeeping. It's just say that this presentation aims at sharing knowledge. It doesn't reflect the position of the company I'm working for right now, which is Repsol, based in Spain, or the European Commission, where I'm expert at the European Commission or US Department of Energy. It's just this presentation is mainly to share some of the knowledge I acquired during my years of in North America, Europe, and the Middle East. So let's see, Repsol Technology Lab. First, quick introduction. This is Repsol is a multi-energy company based with headquarters in Spain, in Madrid, and with locations in North America, in Houston, Texas, South America, Asia, and also North Africa. And there is also, the activities include the production of oil and gas, refining, and also gas stations, but also energy transition. And through our technology lab, which is the R&D arm of Repsol, we have over 230 experts with a budget of over 64 million euros, and capabilities in different areas that can be applied to energy, but also to mining. And this we can compare it, I can tell you, we can compare it to UM6P. UM6P is really an R&D unit with a lot of researchers, different nationalities, with really interesting budget, and with also options for having startups, having students, and also having experts coming and sharing from different nationalities. So for me, this is really what I see that is really a very, very great experience to be speaking here at UM6P. So the R&D, again, patents, etc. So I'm not going to talk. Let me just talk a little bit about the different aspects we're covering in the research and development part of Repsol, where you can see low carbon comes at #1, because this is really an emergency. This is urgent task to address. And not only by oil and gas or by mining, but by everyone, by you, me, and everyone. The mobility, we need people to be able to go, to travel, to exchange. This is really important, so the mobility. And also optimization. When you have an asset, you can consider it as your own business, you start your own business, you can consider it as your mine, or as your oil or gas field. This is your asset. How can you optimize it? And optimizing, and it was mentioned by the previous speaker, and probably also surely by the next one, is optimizing is using less resources and having less impact on the environment. So this is a kind of optimization, and you can use artificial intelligence. You can use, it's mentioned IA because it's in Spanish, inteligencia artificial. So sorry for this one. Deep learning, IoT, etc. So, and you can see here that those are really topics that are covering everyone, every sector, not only oil and gas. So this is the second point, which is really important, and this is, I mean, for me, it's crucial, is open innovation. Open innovation meaning sharing, meaning, for example, you have a challenge, you post it on the web, and you ask people from around the world to try to solve it. So open innovation is really key for solving the problems of the future. So you have here, I'll just skip the one. Now let's go a little bit more to the mining. And those are two statements that you can see that are coming from Pricewaterhouse and also from another organization associated to this one. And it tells you that the miners can no longer depend on portfolios, on yesterday's portfolios and practices. Remember, practices. And we're talking about the mine. So, and this is based on a poll of Pricewaterhouse for around, I think it was quite substantial number of CEOs, and 41%, this is really the difficult part, 41% don't think their company will be economically viable. 41% not economically viable using the current technologies in the next 10 years. 10 years is tomorrow. So if they continue the current path, so we have to change something. So we have really to address the different challenges. And we cannot depend on yesterday's portfolio, it was mentioned already before, and practices. So, and the second point, which is really highlighted, was highlighted by the International Council on Mining and Metals, is related to greenhouse emissions. Those are the main, you know that, it's not really news to you. One of the main causes of rising global warming, and metal and mining account for 10% of it, between 8 and 10% of it. We want to address the challenges of greenhouse. Mining will be one of the key elements, or one of the key players to do that, to reach the net zero scope 1, 2 emissions. So for those who are not aware, the scope 1 is what you are emitting when you are running your plant or your mine directly. Scope 2, what is called scope 2, is scope 2, let's say you are using electricity coming from somewhere. This electricity is not green or clean. So the emissions that you are emitting using this one are called scope 2. Scope 3 is you are producing, for example, it was mentioned copper. So your copper wire, it's used by someone else to build his own product, and his product is emitting CO2. You have liability on part of it. This is the scope 3. So what we can see is mining materials are everywhere. So everything coming from mining will have impact on scope 1, scope 2, and scope 3. And if we cannot address the scope 1, scope 2, scope 3, we will not be able to reach carbon neutrality by 2050. So let me, I'm sorry for those who are involved a lot in mining, but unfortunately there are a lot of emissions coming from the mining industry, less than oil and gas. So for example, steel, which is crucial. It's very, very important for everything. 1.4 tons per ton of steel, of CO2. 1.4 tons of CO2 emitted per ton of steel. Cobalt, very used very often, 4.1. This is really very, very important. So for every ton of cobalt, you are emitting 4.1 ton of carbon. For copper, it was mentioned before, 4.1, same. And for lithium, which is crucial for the cars of the future and batteries in general, so we are talking about 15 tons. Those numbers are really important. So imagine the number of tons produced every year. I'm talking about every year. Now let's go and talk about two other elements I didn't mention here because they are really scary. Platinum and gold. Gold, 2,000 per one. So that means producing 1 ton of gold is 2,000 of, you're emitting 2,000 tons of CO2, or 1 kilogram, 2,000. And platinum is 20,000. So mining, so there is a need to do something. And this is, you see on the right-hand picture, the way to do that, to address that. It's an issue, but it's not a big issue. We can address it. And to address it, there is what we call the CCUS, which is carbon capture, utilization, and storage. And it's really, technology is there. We just need to apply it. The goal is to capture the CO2 we're emitting and transport it, compress it, clean it, transport it, then either use it to generate biofuel, for example, or to store it underground. And for this, mining is bringing a great opportunity. Why? Because there is what we call the mineralization. There are the waste, the mine wastes, where those mine wastes can capture your CO2 and keep it forever. So mining is really interesting a sector to help decarbonizing decarbonizing and reaching the targets. And companies started already. You can see on the left-hand side that BHP, Rio Tinto, all the companies, they already have some targets for 2050, which means that there is a willingness there. There is a will to go and do there. I'm not going to talk about the one on the right-hand side, which is just giving you some numbers. But you see that some companies are already carbon neutral. You can see, so it's this one. So you can see here, already carbon neutral. Some others are getting their emissions targets by 2050. You have even 1, 2 by 2030, some by 2035, 2030. So there is work that started already by the mining industry, which is great and worth to mention, that to address the carbon, the issues of CO2, too much CO2 in the atmosphere. So for storing the CO2, the value chain is really simple, and it's well known by everyone. You need to find place, so capacity, storage capacity. You need to make sure that whatever you store there will stay there. You need to be able to transport it before storing it, and you need to make sure that you are monitoring this CO2 to make sure it's not gonna leak, it's not gonna go out. And believe it or not, technology is there. The way to do it is how to put the right workflow. So technology is there, but we still have a need for innovation, so there is still opportunity to develop new ideas. The last one, which is stakeholders, is to talk to people, because we need to know that. It's really important is you want to do some kind of innovation, you need to get your stakeholders aligned with you. So you need to talk to the populations, and especially for the mining, we are touching everyone, every person. So that means we need to explain what we are doing. So this part, which is stakeholders, is really important, and education, as it was mentioned before several times, is really, really important. We need to educate people. We need to educate not only students, but we need also to educate populations on what we are doing. So those are really important points to keep in mind as soon as you hear about carbon capture and storage. Just remember those 5 pillars. So technology, yes, there is a need for technology. There is a need for innovation. We need the new generation. We need the old generation. We need everyone to think and to develop. And UM6P is offering a great platform to do that, and other universities as well, is to see how we can, for example, you see on the right-hand side, how we can estimate the cost, because at the end of the day, it has to, I mean, we have to pay for something, but it doesn't need to be a lot. How to model it, and the same thing, this is a really important part, how to model how this CO2 will propagate, and also to use, to advance to do, for example, some reactive transport. You are transporting the CO2 somewhere, you are storing somewhere, what kind of chemical reaction will happen over time? And for this, we have some examples. So for example, the mineralization. This is one of the aspects, one of the topics that are, I would say, well known and not really known. Because we're doing that. I mean, the system is very simple, is replicating what Mother Nature is doing. Mother Nature is taking the CO2, mixing it with water, and try and putting it in contact with rocks. And by putting it in contact with rocks, you will store it. So mineralization is really a very important aspect to take into account when we're talking about storing CO2 in different elements. So you can see here that first we need to find the location, and you can see from the right-hand side. So there are technologies to be developed, there are workflows to be done. You need to build your mineralization site, and you can see that the monitoring the well, you need to drill a well, you need to design and drill the well, and to locate a specific type of rocks. Those specific type of rocks, and mining experts are very familiar with this, which is mafic and ultramafic, because the goal is to get this calcium and magnesium liberated from the rock and attached to the CO2. To do what? To generate carbonates. It's exactly what Mother Nature is doing since billions of years. We're just trying to replicate it and to make it faster. So, and also the technology to inject it. So there is a need to develop new technology to inject it, to find water to do it, and also the last one, which is to monitor the mineralization. What happened is the mineralization will offer a lot of opportunities, and you can see with me the numbers. I'll just, so you can see, there is really a potential of, there is a potential of up to 85 to 15 tons of CO2 to be removed by 15,000 tons that was already acquired by Shopify, by Climeworks, and Carbon Engineering. And there is, the cost will be around 17 to 85. Companies like Microsoft right now, they're offering 500. So if you have technique to store CO2, mineralize your CO2, you can sell them the credit. So that means it will cost you 80 euros per ton, and you can sell it for 400, 500. Netflix is also doing the same thing, 500. So there is an opportunity for business for you guys if you want to start your own startup. That's really great. And they are startup, by the way, doing this. And to mineralize, and this is really interesting for mineralization, it takes, I put 10 years, but between 1 and 3 years. It's not more than that. From injection to mineral trapping. And mineral trapping, that means your CO2 will stay there forever. I say forever, it's not 100 years. We're talking about millions of years. And there is a potential of 11,500 billion tons of locations where this CO2 can be mineralized. So let's move a little bit. You see on the right, by the way, on the right-hand side, there's the locations where you can store your CO2 using mineralization, and those can be onshore and offshore. And onshore is offshore, I mean, you know where the location, but onshore it's also with mining. And this is very, very broad locations. So basalt, for those who are doing some mining near basalt or in the basalt are the best, really the best place to store CO2 because we have an availability of calcium and magnesium. So there is, for example, in Europe, you can see the number, 4,000 billion tons of CO2 that can be done easily. I mean, easily. You need the installation, you need the technology. And it will not take you more than 2 years to mineralize your CO2. CO2, the mineralization can be done in different ways. Can be done on surface. And those are examples done right now. It was mentioned again before, cement. So you can generate a type of cement by just mineralizing your CO2. So you have first cement, which is clean. So you are capturing the cement, you are taking out the CO2 from the atmosphere and storing it in cement. Cement, by the way, it produces, for 1 ton of cement, is 500 kilograms of CO2. So imagine if this, you can get it out, and it's, I think, number 6.6, if I was mistaken, gigatons of China that used 6.6 of cement. So imagine the amount of CO2 that they emitted in the atmosphere. By getting your CO2 through the atmosphere as a mineralizing it, you can get rid of this. Building materials, and also you can precipitate it. So it's very simple. I mean, the same thing is you can use those fly ash, you can use water, you can use products from steel production or from the cement, and you just, it's really, the system is really simple. Do what we call the leaching, which is liberating the CO2, the calcium, for example, and using some heat from power plant and fixing it and do this mineralization that you can get through cement. The second way of doing it is underground. And underground, this is where we have the biggest potential in rocks at 500, 800, maximum 1,000 meters, which is the depth at which the mine can operate safely. So you can store it. You can store the CO2 over there. The only thing you need to do is to mix it with water. So you mix it with water and it becomes acid. So the pH will be reduced, and what happens, it will dissolve the material, and this dissolving the material will liberate the calcium, and the calcium will combine with CO2. Again, it's very simple, basic chemical reaction that we learn at the age of, I think, 13 or 14 in middle class. So it's nothing really magic about it, but the goal is how to apply it. So you can have up to 250 to 500 kilograms of CO2 per kilogram of rock that you can really store in a really efficient way. So this technique is very promising technique. And again, it's just mimicking what Mother Nature is doing. So we're not hurting, we're not harming the environment. We're trying to save the environment. So the mineralization, very simple, and I see that I think I'm gonna go a little bit faster here. You see how things are happening. Really simple is water plus carbon dioxide. You form the carbon acid. Then after that, you have the bicarbonates, and you liberate some hydrogen. This hydrogen, which make the water acid, will help liberating calcium and then or magnesium for dolomite. And with this, you can get your solid stable carbon mineral. Mention the word stable, very important. There is an existing project called Carbfix in Iceland, 50,000 tons of CO2. By the way, Switzerland is shipping part of its CO2 to be stored in Iceland. And recently, Rio Tinto, which is a large mining company, has also have an agreement in 2021 to work on mineralization of CO2 in mine waste. So it's really simple, the process. You have the goal, you have the tracers, you have the monitoring, and you do some kind of hydrology, lab experiment, and geochemical modeling. Second one, which is really interesting, from Cornell University. This is really interesting. The reason is you are generating hydrogen. So for those who are really, who like to get some natural hydrogen, natural hydrogen is coming when you have a type of rocks leached by, in contact with water, it will liberate the hydrogen. So the project with Cornell University, it's that you have something which is combining two aspects. The first aspect, which is you are storing the CO2. So you have your mine, you are capturing your CO2 and using alkaline amine to capture the CO2. And after that, you can mineralize it. But during the process, there is a way also to liberate the hydrogen, natural hydrogen, that you can use for reducing the carbon footprint or your production. Typically for mining, 50% of the CO2 emissions are coming from trucks using diesel. So if somehow you can use either electrical trucks or you can use the fuel as hydrogen, that will reduce a lot your emissions of CO2. So you can see here that with mineralization, we can store using natural way your CO2 permanently, million years or even billion years. You can also generate some byproducts, which could be the hydrogen, in safe way without harming the environment. And the third example, and let me see if I can, I don't know if I can, there is a movie. I don't know if we can run it. I don't know how we can, because there is, in all cases, this is a project if we cannot run the movie. Yeah. Sorry. Okay, but that's okay. Let me just tell you this one, which is a project that was started in 2023. The goal was to study different outcrops. So what we did is we defined the different outcrops, and from those outcrops, we selected a different type of rocks, and we went to the lab, and we ran those one in the lab. And we saw the part which is the precipitation and the cementation of the elements. Again, the process, the workflow is. No, we can? Sorry. Let me see. No. That's okay. So just to tell you that this kind of project, it took us just 3 months to set it up and to do the lab measurement. So the mineralization part is, and you can just go to the website if you want to see the video. There is a website. The project is called the Picasso project, and it will just show you how simple is the process of doing mineralization. To summarize, and I hope I didn't go too much, I mean, I didn't take much time. The carbonation of chemical, which is mineralization, is containing calcium and magnesium, such as calcite, which, by the way, represents, I forgot to mention that, 15% of the sediments of in the world, or magnesite, through a natural process, which thanks to the hydrolysis of CO2 in moist and air or water. Carbonation is, or mineralization, is well adapted to the to the mining industry. We're using it in the oil industry, but it's also adapted to the mining industry. And carbonate, and this is really, keep it in mind, carbonate material present are, the storage is permanent. This is the only way to make it permanent. Permanent, and it's circular. If you are doing for what we call in situ, underground, it's permanent because you are creating minerals, you are creating carbonates. Or if you are using the CO2 for buildings, ashes, fly ashes, for example, you can also generate cement, which is clean cement. So the potential per year is 8 million tons. Right now, we're talking about less than 100 million, no, less than 1 million tons that we are capturing from the air and storing. So mineralization can give you 8 times what you have. Current emissions of CO2, I mean the statistics, 40 billion tons of CO2 per year in 2024. So there is a big amount of CO2, and it's not the current technology of capturing and storing, which is not even 1 million ton, that will help. But combining different technologies like mineralization, at least it will move the needle a little bit. So, and the other thing which is, and again, another opportunity for you guys if you want to develop your own business, if you are capturing the CO2 and storing it in minerals, it will give you credit. That's what they call it, BECS. So the BECS is the CO2 coming from incinerator, and you store it as mineralization. You can sell it, again, to Microsoft, to Netflix, and to the other companies. So it's an opportunity to develop, for example, a startup, and you start selling those carbon credits. But still, more R&D is needed to overcome the quality of the CO2 and also the transport, the characterization of host rocks for geoscience. It was mentioned before, the importance of geoscience is critical. It's critical. So, for example, characterization of host rock, and also to do more on understanding the mineralization process and to understand the geochemical reactions that will help mineralizing your CO2 faster and in efficient manner. So with this, I would like to thank you for your attention, and if you have any questions, let me know. Yes.
Thank you, Professor Sofiq. It's an honor to have you here and talk about such an important innovation in the construction industry, for the construction industry.
Exactly.
I'm Yahya Al-Berdei. I'm a freshly Doctor of Civil Engineering from the JSMI, and I worked on other pathways to reduce the carbon emissions. And in our materials, we've uncovered carbonate materials, including some very interesting rock types. And you talked about recycled aggregates in concrete,
Yes.
but we also have much more interesting candidates in Morocco. Do you have any more forward thinking, how we can upgrade the cycle, the experience we had in Europe, and apply it in a better way, considering local materials?
Yeah. No, thanks a lot for the comment, and congratulations for the work you are doing. That's great. Yes. Morocco is offers a lot of opportunities with the type of rocks and the different type of mines, for at least for cement. And I'll be talking about cement because I was involved with the company, Lafarge Holcim. with the research center to see how we can generate those cement from CO2. So, and they found again that Morocco is very good candidate. For aggregate, it's different. So there is another project, I was also participating, European project, where for construction material, we're just recovering those kind of waste and mineralizing them and making them. The challenge that we had, again for full transparency, is to make it certified. Construction material need to be certified before you can use them. So the aggregate need to be certified. But we're really almost there. And again, this, the presence, the diversity of the resources in Morocco, of the rocks, of the outcrops, of the mines, they're great, they're huge. So looking forward to work to see how we can really make that realistic, going from pilot to something which is at industrial level.
Thank you. I have another question,
yeah, please.
if you may. About the process of industrialization.
Yes.
We have facilitated many, we have bridged many gaps we had between the industry and the mining sector through efforts of different projects. And it's very encouraging to work on the industrialization. What are your thoughts about succeeding in this way, considering all the good relationships and the easiness we have here in Morocco? As a case study with the industry partners, what are the keys that we can benefit from in order to push this technology, including innovative technology?
Excellent. Again, another excellent remark. You need to involve the industrial from day one. When I say day one, from TRL 1, really from the starting of the design, you need to involve all the stakeholders. And the stakeholders, the key stakeholder will be the industrial, but also regulation. When I say regulation, is government, to make sure that they will facilitate the way, they will adjust the regulation to make your life easier when you are going to industrial. So involve those two key stakeholders, which is government for regulation, which is industrial as the off-taker, as the end user, from day one, really. Don't wait until you reach TRL 5 or 6. Start really very early. And be transparent. Transparency is key. As industrial, my working with Repsol, when we work with research centers, that's what you ask them. Be transparent. It works, it's okay. It doesn't work, we'll try to see to fix it. That's no problem. Okay?
Thank you so much, Dr. Tawfiq, for your nice presentation and the discussion. If you still have questions, please join Tawfiq during the coffee break or during the panel. Thank you.
Thank you.
So now we'll move to our last presentation before the panel. So please welcome Dr. Harwood Malcolm, who has been a part of the global mining industry for around 30 years and has worked toward the supply chain from exploration, draw to shipping and marketing. His first automation project was to implement a fully autonomous crusher and winder system of around 1.2 kilometers underground over 25 years ago, and was recently involved in deploying autonomous haul tracks over 4,000 meters above sea level in the Chilean Andes of South America. Recently, Malcolm has joined OCP Group in the SBU Mining. Future is Mine, and he is the head of Mining 5.0. He will talk about the Mining 5.0. Thank you, Malcolm.
Good afternoon, everyone. As you can tell, I'm from Australia. I've been in your lovely country of Morocco for 7 weeks. As Abdel has just said, I've recently joined OCP as Head of Mining 5.0. So I'll give you a bit of an agenda to start with. Us miners like to have things pretty well organised and planned. So a quick agenda. I'll give you a bit of A safety share, again, as Richard mentioned early on, the mining industry does have a very bad history of bad safety, of causing lots of harm to lots of people. But through many initiatives over the years, and certainly going forward with the advent of technology and some of the stuff I'll go through today, it's becoming a lot safer. Look at the bit of history of OCP, bit of the background that's got us to where we are, and some of the Mining 5.0 program going forward. So while I probably don't want to show this slide now after what Richard mentioned to start with, this is an incident from the mining industry. As I mentioned, we do harm some people. This is a particularly interesting on the Mining 5.0 pathway. This was reported in the global media while I was on a project in South Africa looking to implement autonomous trucks. This is indeed an autonomous truck. The way we can tell that is, can't quite see. Up on the top right-hand corner, there are two antennas up the top, which are GPS receivers to give the position of the truck. So we know it's an autonomous truck. However, under deeper investigation, this was actually human error. The truck was being used in manual mode. It wasn't in autonomous. The electrician, the shift maintenance guy, went to the truck to have a look at what was wrong with it, decided that he couldn't fix it, and wanted to drive it back to the workshop, and ran over his own vehicle. So for me, this really starts bringing up quite a few of some of the opportunities that Richard particularly mentioned in the mining industry, and also some of my key roles. Implementing technology in any industry, mining or anything else, requires a lot of change management and a lot of effort to be able to make sure that we effect the change in this sort of case where behaviours, normal mining practices, this person should never have parked the vehicle there. Why did he change his mind? Why did he park in that sort of position? So I think Richard started to present some of these things about how the industry is changing over time, how we can make it a lot safer and move forward. So a bit of background on OCP for those that don't know. OCP, as was mentioned, is the world's largest phosphate producer by annual tonnes. We produce from 3 major regions throughout Morocco, and then through a supply chain, move from the mines towards the ports, through chemical plants, and then sell to market. Yes, I must admit as well, like Richard, I'm a geophysicist, so I must have my obligatory rock photos. Not quite as sexy as Richard's, but a lithological model is reasonably close. But it gives some of the complexity to what we do. This face is around 60 metres high and has got 6 layers of phosphate in it. So that's what we mine. So we have to remove the first 15 to 20 metres of overburden, of waste, before we can get any phosphate out at all. And then through various processes of identifying the material, the quality, and its placement, is we go through other processes which I'll describe some as we go on, so we can identify the ore in the mine, separate the waste, and help our mining process. Looking at how we used to mine, and we still do across much of our operation, is up the top level, unfortunately the point is not very bright, is we remove that first 15 metres of waste. We usually have to drill it to break it up so we can move it, and then we use bulldozers to push that waste into where we've already dug a hole. We then move down a bit further. Where's my pointer? The little machine there in red is called a dragline. It's got a very large bucket on it. The size of that bucket is big enough to fit probably 2 large four-wheel drives in it. So a very large bucket, and it can lift up material, lift up waste, and it can throw it 80 metres. So a very efficient machine at moving material. As we get further down the mine, that machine is unable to lift high enough to get it out of the mine, so we go back in the last picture there to truck and shovel, what we call truck and shovel, where we're using an excavator, a backhoe, to load dump trucks and cart the material out. And as you'll see through there in the coloured bands, which are the ore bands, we use smaller trucks to be able to manage those thin layers. On to the exciting bit. In contrast to Richard's dirty slide from Google, ChatGPT is a lot happier about mining. This looks nice and clean. So this is a ChatGPT rendition of what we're currently targeting at OCP, which, as Richard mentioned, is mining 4.0, where we're starting to implement technology. We're starting to have some pretty dashboards. Obviously, as we go down and put more technology on all our machines, one great advantage is they give us lots of data. So we can use that data in dashboards to help us manage the mining process. We can understand the speed of trucks, where they're going too fast, where they're going too slow, how efficient our diggers are, and as well on the maintenance side. We can start understanding when a machine is going to fail before it fails. And of course, if we can bring that machine in before it fails and do some planned maintenance on it, then we're not stopping the mine. If that machine breaks down in the mining operation, it's a breakdown event, and that will normally stop the mine while we get people there to work on it and maybe work around it. So some really higher uses of data and important ways we can build. And that probably brings me back to that change management piece. As we put these machines and these technologies in, one of the key things is training. How do we train our people on the new technology? Or I suppose before that, how do we build the new technology? Where are we getting this new technology from? As we bring the technology in, how do we train people? And for example, some of the projects I've worked on, I mentioned that project in South Africa. The project in South Africa I was working on, the trucks they were using were traditional mechanical drive trucks, like your car at home, where the engine is connected to a gearbox, through a tail shaft to the back wheels. We were going to put in electric drive motors. So that now means we'd had to have a whole new skill set of high voltage electricians. That we found going through South Africa, nobody in South Africa had ever worked on I think there's something like 18,000 volts of power supply on board the truck. And back to some of Richard's calculations in terms of the amount of copper required to move that electricity around. So some of these skills is very much where we start doing these sort of things. And the other thing, unfortunately, and I might steal that slide from Richard, particularly underground, one of the big issues we have at the moment with automation is the technology is very limited. There's very limited integration between different autonomous systems, different technologies. One of the most obvious of this was when I was working on a project up in the UK in the last few years to build an underground mine. An autonomous truck cannot be loaded underground by an autonomous loader. So to be able to make that system work, a human has to go underground, turn one of the systems into manual mode so the other one can load it. That's where we currently are. That's a technology. That's a challenge to fix as we go forward, is to how to bring forward these technologies and how do we start integrating. Aside from the technology piece, back to the mining, the first thing we're doing is removing the drag lines. There's some reasons behind this. Going forward, one of OCP's key drivers is decarbonisation. How do we get, as was just pointed out, rid of that 50% diesel burn through our mining operation? We've chosen at this stage, as you've probably seen in the media, to partner with Fortescue and implement battery electric trucks. So to make that work in our entire mining model, we're going 100% to truck and shovel to be able to utilise those big trucks in a more efficient way. And the other note I wrote here is dozers. As you're probably aware, a bulldozer is a very big machine, 40 tonne up to about 70 or 80 tonnes for a big dozer. Takes a lot of power, and nobody yet has been able to solve running those on batteries. They're hoping to have some by 2035, but not within our time frame. Stole this one directly from the GMG manual. GMG, I'm not sure many people are aware, is the Global Mining Guidelines Group, currently based out of Australia. It was formed 20 years ago, 15 years ago, as a group of mining and mining services companies to help define the key aspects of mining and how to bring things together. This particular article is taken out of the automation paper and how to implement automation within your business, and defines quite clearly the 5 levels of automation. When OCP started mining 100 years ago, we were definitely level 1. Manual operated, hand operated with donkeys and maybe the odd train or two. Level 2, partial automation, is the sort of thing you're used to in your car. Well, some cars are changing now, that can do cruise control, automatic headlights, automatic wipers. They can do partial things automation. And this is also where we expect our dig units to stop. Our dig units have an operator in them, and we expect those machines will be delivered to us later this year that will help the operator to complete their functions. We call that operator assist. Level 3 automation is what we're currently implementing in our brand new Benguria wash plant. What that gives us is the ability to run the plant without people in the plant. It can operate basically by itself, without a person in the control room. This provides us a significant improvement in safety because we don't have people out working in the dangerous environment, in the hot weather, and where they can be harmed. Our autonomous trucks, that I'll talk about shortly, are currently sitting about a level 4. They can do most of their tasks by themselves, but they're not like Google Maps and they can't figure their way around. Our intention by the end of this year is to get our wash plant to full level 5 autonomous by putting in some AI systems and some fuzzy logic. So really trying to get our operation as far as we can up to that level 5 automation. So I talked a bit about autonomous haulage. So I'll focus on that, but use some other examples as we go through. Essentially, autonomous haulage system is broken into 3 components. There's our truck, our infrastructure, our network, and our control room. Our control room could be beside the mine, or in Australia, some of these control rooms are 2,500 kilometres away. So back to some of the comments made before. Lots of jobs coming up in mining are not within the mine. Some of the people working in these control rooms, they go home every night to their own homes. Some of the projects I've worked on, we have flexible hours. Some of the people I've worked with in Australia are return to work mums. So they can take the kids to school in the morning, come and work during the day, pick up the kids in the afternoon, and still participate in the mining community. So it really provides us some flexibility as we go forward. Looking at our truck, current mining trucks are extremely dumb. Sorry, I didn't go to this page. Our current mining trucks are extremely dumb. It's where they're built up over the time. Autonomous trucks started being produced in the late 2000s, 2007, 2008, and still largely carry the same technology. So all the truck can do is those 8 odd tasks I've listed there. The basic functions required to operate a truck. Start, turn, move, stop, dump is all they can do. The rest is provided by the system. The other things I've highlighted there are for the people. The safety systems. How do we ensure that if we've got these dumb trucks running around, that they don't run into people? They know where they're going because they've got the GPS antennas, and they know where everyone else is because they've all got GPS antennas, but these are in there as a personal protection equipment to be able to keep our people safe. Extending that a bit further, looking at that safety layer, critical to these machines, and our people working the mines. And this is currently a very large place of research and as an opportunity for people to start doing more in helping these, is how do we get these trucks to observe the environment around them? The items I've listed there, the LiDARs, the radars, some people do try cameras, but unfortunately cameras don't work in dusty mines, are used to be able to help the truck identify objects around it, as well as anything around that it may cause it a problem. Water on the road, damage to the road surface, or anything else. In Morocco's case, dogs. In Australia's case, we've got large birds that stop these trucks quite regularly. In South Africa, we had to worry about deer and other animals of delicacies. Looking at the next layer of security, as I mentioned, and what I usually describe these trucks as, if anybody at home has got one of those robot vacuum cleaners that go around and clean the house, that is about 8 or 10 times more smart than a dump truck. So again, we've got to put in a lot of controls to make sure people going into that area have all the training required to be there and are safe in their activities. Back looking at this again from a technology point of view, these trucks run in a virtual world. There's a huge requirement to make sure that we maintain that virtual world equivalent to the real world. We have a number of people that manage this back in the back office, doing data science activities, looking at data, looking at why trucks go where they shouldn't be. But the other big thing we've done is by taking operators out of the trucks, we've removed eyes from out of the mine. So people can't see what's going on. So we need to replace that with some other activities. The image on the top there, where we have people going back out there and doing surveys to be able to verify these things. And back to my comment before about some of the new jobs coming up for people as we go and implement some of this technology. There's a lot of work that we need to do in designing the technology, implementing the technology, all the data science. I mentioned some of these trucks, for example, current generation Caterpillar truck can send out over 1 megabyte of data a second. If you've got a fleet of 120 of these, plus other machines, there's a whole data science project for someone to work out where to put the data, let alone actually get some value out of it. There we go, Don. looking at some of the things we've got ahead of us as we start implementing this technology is what I call the 4 critical focus areas. I've already covered, I think, a bit on the safety side as how we manage the safety component and make sure that implementing technology addresses some of those basic risks, but also doesn't introduce any new ones. There's the technology itself. How do we implement the technology? But what other technologies do we need to put in? And I mentioned, well, one of the issues we have is we take people out of the operation, which means people are not observing. That means maybe we need to run a drone around the site every 3 or 4 hours to be able to understand what's going on. We need people to interpret that data and manage that data. I was sitting in a presentation, I think this morning, where somebody's come up with a new novel technique where they can go and scan the mine and being able to pick up some differentiation, some areas where the roads are not up to standard, and then can present that back to the workers to be able to fix up some of those issues. People. Now, people are a very key part of this process. Clearly, there's a number of roles that are going to change. We're going to lose some truck drivers. We're going to create a whole new lot of skill sets. But our entire workforce has to be upskilled. This presentation is actually one that I've run around the world in various forms that I call the Introduction to Autonomous Mining, just to give some people some ideas of some of the issues we have to manage our trucking fleets and how to move forward and start deep diving some of these issues. And change management. Change management on these things is at many levels. There's a project change management that we need people to help with. We've got the change management of the training and putting things in. But as I mentioned, these trucks are extremely dumb. You can't go up to them at 5 o'clock on a Friday afternoon and say, I want you to move to the other side of the mine and start mining. So we need to have our mine planning teams that are well advanced in terms of being able to understand scenarios and scenario planning so we can better manage some of these change issues as they come up. My final slide. Another nice pretty slide, but mining 5.0. Again, nice and clean, some lovely suits. Probably looks more like a Hollywood movie than anything else. But one of the big things between mining 4 and mining 5. In mining 4, I describe that it's us working for the machines. As I said, they're very dumb. We've got to do a lot of things to be able to work for the machines. They can't talk together. They can't work with each other. Going towards mining 5, and it's a challenge that I've certainly got and I brought out to anyone that wants to help me, is how do we bring all that back together? How do we start utilising this data better that we get to be able to run our operation better? How do we address some of those challenges where we've got people taken out? So do we put instruments back in the field to be able to do better grade monitoring? How do we better manage our tyres? How do we better manage all the issues in the field and then back into the mining operation? How can we better plan? How do we better get some other information to help our teams that, I think Richard mentioned that a lot of our teams are both working in the centre control room, but some are also working from home. In that project that was mentioned that I worked in South America, I did not go to site for 18 months. I did everything completely remotely. So this is some of the challenges we have coming forward. How can we design new technology, identify new problems, find solutions, and then implement within the mining industry? I have to say that I'm a miner, but certainly within other industries as well. How can we start bringing these sort of things together and produce a better ecosphere for our people? Addressing one of the things I thought Richard was going to say when we start talking about lack of resources. Many people are talking about mining asteroids, mining out in space. Again, if we can get it right on Earth first and be able to get our systems to work here, how can we move into space? And certainly there's a big lot of research that goes on in Australia between the mining industry and the space industry to be able to head towards this area. So a quick intro to Mining 5.0. I think I'm right on time. Any questions for people?
So thank you so much, Mal, for all the insightful regarding the mining 5.0. It's very interesting as we are working for that. Just I have a question with Moroccan context, because you know that Moroccan, we are suffering for the job creation. And mining 5.0, it's autonomous 100%. And we see that it will be reducing the need of people into the mine. So how you see this? This is good to move forward to the mining, to reduce the people, how we can have this optimal solution between job creation and accelerating in the innovation and the mining 5.0. Thank you so much.
No worries, good question. I'll answer this on a few different ways. Certainly, as I mentioned, there is a huge opportunity for new skills, skills that don't currently exist. Many of our operations around the world, certainly within UM6P, we don't collect much data. Going down this path, there's a whole new requirement for data science people. I was sitting in a presentation the other day with a head of data science, and some of the concepts he's come up with in terms of opportunities he's identified just by looking at data, spin off a whole new ecosphere of research and development projects to go and work on new sensors, different ways to do speed detection, different ways to do many parts of the operation. So there's certainly that side of it. In South Africa is probably one of my biggest projects that I've been through one of these, where we had a fleet of 800 operators that we had to bring back to, I think the AHS team was back to about 150 people. So in terms of raw numbers, yeah, it's a scary number. But as I mentioned, when we start looking at the other jobs we created, we had to put on 50 new high voltage sparkies. I had to put on a team of, I think it was 20 extra mine planners. And by the time I got back through all these extra job roles that we created, I only lost in all, I think, 150 people. And as part of my working with the community I did in South Africa, the local tribes people down there said that one of their concerns was with mining, that particularly gold mining, that the gold miners came in for 3 or 5 years, the average life of a gold mine, and then left. So all the people from the community, all the elders' kids had gone into mining and had gone on this train of mining and had forgot about farming. So put some time and effort back into growing some of those community activities to be able to get people back into farming. Does that help?
Thank you, Malcolm, for your nice presentation and discussion. Please, if you still have a question, please come and discuss with Malcolm during the coffee break. So we'll see you in 20 minutes for the panel discussion. Thank you.
من دائما أنا هو الشاعر.
شكرا. Hi again, and thank you for your interest and for being here for this interesting panel discussion that will focus on envisioning the mind of the future, challenges and opportunities among the emergent constraints. So we have chosen for you 6 panelists with very diversified profiles from different mining life cycle, from both industry and academia. So I'll invite the panelists to join the floor. I will start with Richard Lilly, please. Taufik. Malcolm. The fourth panelist is Talal Al-Khairi, who is the head of sustainability in mining. Usama Khadiri, who is the head of Geosciences and Strategic Mining Growth from OCP. And finally, Mustafa Ben Zazoua as the director of GSMI. So, dear panelists, thank you for accepting our invitation to take part of this panel. You all agree that mining is necessary for life and necessary for human development. We know that metals are necessary for energy transition, for infrastructure, and for tomorrow. However, the constraints of mining of the past are not the same of today. We are living a lot of constraints related to permitting, to social constraint, sustainability, and funding accessibility. So these challenges are distributed from the exploration at the stage of defining the ore bodies to the environmental and the mine closure. So I will start with Usama as the head of Geosciences and Strategic Mining Growth. So dear Usama, as you know that in the past we have seen a lot of ore body delimitation and exploration using some conventional ways. But today, as I said, the constraints are not the same. We are in an era of the big data. We are in the era of artificial intelligence. So the question for you, how will the advancement in AI, machine learning, and big data transform mineral exploration strategies?
Hello? It's okay? Okay. Hello, everyone, and good evening. It's first a pleasure to be a part of this prestigious panel and participate on it. And thank you, Abdel-Latif, for your question. But it's not just a question, it's a reflection. It's that's with 3 concepts. We are mentioned data, big data, AI, and machine learning. And it's important, in my point of view, to start talking about data. Data, it's which serves as a foundation for AI technologies. And as you know, geosciences, we are dealing with generating a big volume of data in different forms and different kinds of data. And it represents the key asset of that fuels the machine learning and enables AI to process, analyze, and also support making decisions. Okay, at OCP, and especially in the SBU mining, in collaboration with the UM6P, through GSMI department, we are investing heavily in several in cutting-edge analytical platforms. In all the value chain, we are starting at platform for geophysics, platform for core scanning, geochemistry, microanalysis, and so on. And all these platforms are generating a big amount of data of high resolution information that we have to master and to develop. And there is where AI and machine learning come into it. And here we are talking about machine learning. It enables to patterns recognition and also predictive modeling. And at the other way, AI takes it in a step further to processing, analyzing, and making informed decisions. And for example, I will just give an example of what can AI tools highlight some unconformities, on some mineralizations patterns that the traditional exploration expertise might miss. So, and the deal here and the challenge is how to bridge the gap between the traditional exploration expertise and the cutting-edge AI tools. So here we are talking about big data, AI, machine learning. It's no longer a futuristic concept. It's a must to shaping the future and shaping our manner of how to discover and to develop new resources. So maybe the geoscience is just one, it's not the purpose in mining industry. We have to see the big picture. And the big picture, when I'm talking about the big picture, is the connection between geosciences, mine design, mine planning, and mine planning. It's a predictive concept by definition. And it depends on the accuracy and maybe in inaccuracy. And the operations have to deal with this inaccuracy. And here we have to build the trust between all the stakeholders. We have to build the trust. How? AI is not sufficient. We have to invest in HR. We have to invest in procedures to close the loop between predictions and actions. Okay? And that's what we call the mining reconciliation. And maybe the challenge will be to build an AI-driven or big data-driven mining reconciliation. Okay, thank you.
Thank you, Usama. So, Malcolm, what I have retained from Usama's clarification is now, even from the exploration stage, OCP is more invested in next generation technologies like in characterization, such as core scanning, microanalysis, and so on. The second challenge that they are investing in is how to store data and then how to use this data to predict some functionalities. So there is an aspect of automation. So in your opinion, regarding the mining 5.0, how we can implement digital transformation and AI-driven automation to improve safety and productivity in mining operation?
Very good question. Thanks. Following on exactly from what Osama was just saying, mining is probably one of the most unique industries in that we move from Osama's part of the world where we absolutely know nothing to the end of the mining process where we've taken everything out and we know exactly what was there. So the advantage of digitalisation, of course, is how do we understand some of those errors? How do we bring that understanding further forward in the decision-making process? It is key to how we can mine ore bodies economically. On the other side, so outside the geosciences, as I was mentioning before, the other big opportunity for digital transformation and use of data is maintenance. We go and buy some big expensive pieces of equipment, or as Richard was suggesting before, we try some novel techniques around injection mining. Is how do we better understand the process? How do we understand how those technologies, how those pieces of assets are performing? And how do we move from where some organisations are always having broken equipment and poor maintenance through to having some of the world's best practice in terms of maintenance, planning, so better manage costs, better manage operations, and move forward. So in terms of some of the technology buzzwords on the back there is digital twins. How do we build some of those understandings? Some stuff I'm working with Osama's team at the moment is how do we take the geology model and extend that using AI, and then to the people out in the field, give them some virtual reality glasses so they can see the geology modelling in the field to help understand where we're going and better make better decisions on our mining engineering and mining practices.
Thank you. So, Tawfiq, Malcolm explained that now we have a lot of challenges regarding productivity. When we talk about productivity, we need a lot of engines. There is a lot of effort today that we need to shift to maybe electrification of engines, but today we're still using fuel-based engines. So in your opinion, how can we implement the strategies of CCS to reduce the carbon footprint related to fuel usage in mining?
Thanks a lot, and again, thanks for the invitation. Mining industry can lead the way for reducing the carbon footprint, for reducing in general the CO2 in the atmosphere, which is today is around 442 ppm. So how can we do that? And you mentioned the electrification. Let's again go back to the different types of emissions, the scope 1, scope 2, and scope 3. The scope 1 are the direct emissions, coming, for example, from the trucks. It's 50%, by the way. If you want to know, this is 50% of the CO2 emissions in mining, in average, are coming from the use of diesel or other type of gasoline for the trucks. So the low-hanging fruits are addressing this challenge and say how we can do that. Electrification of trucks, using different type of trucks, improving, or at least improving the engines and improving the consumption to reduce this one. And we get rid of this 50% of the scope 1. So that's one very important point. And it's, again, I mentioned this low-hanging fruit because there is a technology and we have data. It was mentioned again, over and over again. We have data, we have artificial, we have models, we have digital twins that we can use to optimize the process. The second one, which is the scope 2, and again, the scope 2 is, for example, type of electricity you are using. Is it clean or green? Just to tell you, for example, nuclear is clean, hydraulic or hydrogen is green. So how can we do that for the scope 2 and use the clean energy? And we are lucky, by the way, in Morocco, because we have all the types. We have the solar, we have the wind, so we have also technology, we have brains, and we have a lot of, so we have everything, all the ingredients to address this point for the scope 2. The scope 3, it's going to be a little bit hard, and it was mentioned before, is using the copper, etc. So if we can do in a way to reduce the emissions of the production of the copper or The scope 3 is more if you have your mobile, simple example, using wire in your mobile, the emissions of your mobile, and you are producing this copper, you will be really liable for part of it. So this is again another way where we can impact. And the mining industry again, it's very visible. It's critical for the next hundreds of years. So that will be this. Using renewable energy also replacing for the scope 2 is key. Now let's go to another subject which is really dear to my heart, which is the CCS, the part which is hard to abate, hard to get rid of. There is no way. We have to capture it, and we have to store it somewhere, and to store it in a permanent way or to use it. For the moment, unfortunately, the utilization of CO2 is not really neutral, because you are not, in fact, getting rid of CO2. You are just, for example, using fuel like methanol. What you are doing is just postponing. So you are using your CO2 to create fuel, but this fuel, when you burn it, it will generate CO2. It will not add CO2 to the atmosphere, but it's not gonna get rid of it. So this is also something that we need to talk about. And I was mentioning the mining industry because it's talking really to the rocks, and we know a lot about rocks. So we can use the rocks either on surface, as I said, the ex situ, or the in situ underground, to store permanently this CO2 through, for example, mineralization. So this is also, mining industry has the knowledge and has the technology to do that. And to get, in general, even if the word is too really vague, sustainability is really important. So the mining industry can lead the way for the other industries. And when we talk about sustainability, is usage of water, land also, and noise, all this kind of aspects. Mining industry is really important, has the experience. And last but not least, and I will say for me is top of the top, is collaboration. If there is no collaboration among the partners, among the actors, and when I talk about the actors, researchers, very key, research institutes, the operators, all the stakeholders, and government, it's gonna be really hard to reach this carbon neutral. Collaboration, collaboration, and collaboration. Thanks.
Thank you, Sitover. So the collaboration is the key between the different stakeholders to reduce the carbon footprint. What I have understood that reducing carbon footprint today is a must-to-have with the evolving regulations also at the international level. So, Dr. Talal, from a practical point of view, we know that OCP is committed to reduce its carbon footprint by 2050, if I'm correct. So, what are the different strategies that you have employed as a head of sustainability in mining related to renewable energy adoption, emerging technologies, and evolving regulation, as I said, towards reducing the carbon footprint?
Yeah. I think thank you for the question. It's very important. I think to start with is we need to look at sustainability not from the perspective only of having a sustainable business, but thinking about sustainability as a business and as an opportunity. That's just to frame my answer. So from our perspective, as you mentioned, there is targets. So our target is to be carbon neutral by 2030 on scope 1 and 2, and 40 for the 3 scopes. And then there is the SBTI, science-based target, where our objective is basically to be or to reduce 45% of our emission for scope 1 and 2 by 2030 based on the year 2021. The question now is that what is the 3 important dimensions that we have in our decarbonization roadmap? So I can summarize it in energy, technology, and regulation. And there is a 4th dimension which is very important, is embedded in all of those 3 dimensions, is time. So when working in time, it's the big challenge. As I said, we have a target by 2030, so we need to be ready by that time. And then come the first dimension, which is energy. So when we look at our emission, we say, yeah, well, we have a 2021 at mining specifically, maybe 1.17 million ton of CO2 emission. So it's doable by 2030. However, we need to take into account an important parameter, which is growth. So increasing capacity at OCP is very important and a very ambitious objective. So we will have a significant increase in capacity. And if we keep business as usual, so then those emissions will be really huge. So then the challenge gets bigger and bigger in terms of energy. And here, when I'm saying term of energy, say it's renewable energy. As Mr. Tofi said, we are blessed by having solar and wind energy and so on, so we can harvest all those energy. However, there is different, I would say, dimension to that also. So there is investment, there is the increase of energy, there is an important parameter that we are shifting our scope 1 to our scope 2. Basically, we are shifting from fossil fuel to electricity, and that makes our need in energy very huge, so which means a huge need in investment and also design, feasibility studies, and all those questions so do we need to tackle. So all that work is ongoing, and we are working really hard on achieving those targets. The second dimension is technology, and I think all the speakers here, they have touched upon it. But I want to just to highlight one important part. I think Malcolm and Tofi also, they mentioned the fleet mobility that we need to shift for the emission and so on and so on. But at OCP specifically, or mining specifically, we have a big challenge about one type of process, which is drying. So the current situation is we're using fossil base for drying, and it is our big emitter of CO2. So it's much more than the fleet. So we are, I think, more than 50% of our emissions, which means that this shift in technology is very important. And if we look at the markets about the technology, we find that the maturity is not that high to be able to achieve it by 2030. And talking about your question about strategy, so our strategy at OCP Mining is that we choose to go the fast track. Basically, we have what we call ARC, Accelerated Research Center, where we try to test on pilot level in a fast track those technologies, different technologies. We assess the economic part, the technology parts, and so on, to be able to see if we can scale it up quickly and to be ready by 2030. So this is very important and one of the big challenges we have in our roadmap for decarbonization. So the third part is the regulation, as you mentioned. And as you might know, many regulation on European level. We have CBAM, CSRD, CS3D, and so on. So, and the list, it's going on. So as a leader in the industry, so OCP also take one step further on that aspects. Basically, if you look on our targets on decarbonization, is quite high compared to the peers in the industry. So we try to comply in a direct way on those regulations. It's difficult because it's a moving target always. So we try to keep going on the regulation aspects, monitoring to see what we can do, and by a certain time. So this is the third, I would say, dimension. And all of that, I would say, it is all related to time. So timing. If we say maybe 2060 or 2050, so maybe we have time to do it. But it's 2030, it's tomorrow. So all that, so it's a lot of work, a lot of testing, a lot of uncertainties also about the technology and all the evolving regulation. So that makes the equation a bit more complex. Thank you.
Thank you. So, Richard, from the previous answers from our esteemed panelists, they have shared and demonstrated that there is a lot of challenges that the mining industry is facing, from the exploration to mining, mineral processing, environment, but also like decarbonization. To tackle these challenges, we need people to work on that. So the question for you, from your experience, how the mining industry can attract first and then retain people to work in the mining industry?
Cool, thank you for that question. It's a challenge in Australia at the moment. We're seeing reduction in numbers of people studying all science subjects. So biology, chemistry, physics, everything. And traditional pathways mean you have to go to university to get a degree in geology or engineering to get into mining. I've spent a lot of time living in this space between industry and academia and the teaching world. And I think fundamentally, every year I see, essentially people don't know, students don't know about geology, they don't know about mining. Certainly in Australia and Europe, often the message about mining comes from the newspapers, and you don't often see positive stories about mining in the news. It's normally negative regarding pollution, climate change, and links. And again, it's that disconnect between where our modern lives come from and, you know, whether people want to admit that that is part of mining, finding that connection. So I find really, for me, the best way to actually encourage people into the mining industry is to educate from an earlier age. As I mentioned earlier, you know, each year in Australia, particularly the amount of exposure to geoscience and mathematics is becoming less, which is worrying. But most people I know who learn geology at school, or most people like minerals and rocks, and because you can pick them up. It's only when you go to university and it becomes lots of textbooks and equations that people maybe lose interest. So I really think we could be doing much more in schools. And even in Australia, there are many outreach programs. Every state has a different outreach program, but they're always underfunded. They rely on the passion of people who are educators. And it's really challenging to get sustainable funding. In Australia, you know, a lot of these programs work 6 months or a year at a time. There's no sustainability, yet the companies are making billions of dollars and they're not putting the money into school level. So for me, it's finding a method to fund outreach at schools, to train the teachers in geoscience and techniques like that, and somehow to get past this general view that mining is dirty and not good. And I think the work that's happening in automation, the way that we're seeing you know, modern technology advancing into mining, has to start to, you know, images like we're shown with the mine of the future with, you know, robots and drones is much more attractive than underground with a pickaxe. So moving away from that is a slow process, but and again, the answer is collaboration as well. I mentioned there are many different school outreach programs in Australia. They don't talk to each other. So actually just trying to bring people together and find a commonality is very good, and obviously getting some money from investment from the companies is essential, because otherwise, certainly, I can't speak for Morocco, obviously, I'm not sure what the scope is here, but in Australia and Europe, it's the same, they're struggling to find it. So really just more education, younger, and collaboration.
Thank you. So, dear Mustafa, before like attracting people to and retaining people in mining industry, first we need to train them. So, from your previous experience in Quebec, but also here in Morocco, how do you think that the university, and we can take as example GSMI as an institute, can participate in providing the necessary qualified person to accompany this transformative mining?
Thank you, Si Abdelatif, for this question. I think to answer, I have to take it in three parts. The first, and I think Richard told us much about that, is the prerequisite. And the prerequisite, what we know, of course, a background. That's what we learn at the preparatory schools, for example, here in Morocco. But we need also an intellectual preparation for these young people to be attracted then for the mining sector, to develop their skill there. And then the second part of the question is the training, and training, of course, what we need, and UM6P is doing well in this
area. And I have only to recall what is the mission of UM6P is to empower mind for Morocco, but also for Africa. And so the training the future talent is an important mission, and GSMI for the geology and mining sector is trying to do their best. So with the collaboration of OCP, we have, as said by Usama, cutting edge infrastructure. This is very important. Then we need good teacher, good supervisor when we are training at the PhD level. But we are not only targeting PhD level, we are targeting masters and even bachelor degrees. So we have to perform in the pedagogy. This is very important to make it easy using what is now well adopted as the learning by doing, using the AI during teaching. And what is important is to have all training very linked to the real application. This is why we think we are here at Ben Guerir. We are near the mine. You know, the mine have the mission to be an experimental mine. So for us, it's like a huge opportunity that we could catch and use it during this training. And of course, the training, the third part of the answer is maybe to empower the skills and have what is needed in terms of skills to be maybe employed in different sectors. In the academia, if people are interested about academia, and there is need in this part, but also for the industry, there is many opportunities in the industry for our PhDs, our masters, our engineers. So I don't know if I will answer the question, but I take it in three parts. We have to prepare it upstream. We have to work on a good and optimal training, and then try to be in touch with what are the sectors of employment of this student, of these young people.
Thank you, Sir Mustafa. So Usama, there is a common information from the question that we asked for Richard and Professor Mustafa, and both agree that we need to train people that have in somehow a holistic knowledge on the mining industry, because we need to consider the challenge of the main operation or the mineral processing during, I would say, the planning or even the 3D geological model. So the question for you, and this approach is known as geometallurgy. What role does geometallurgy play in optimizing mining operation, but especially in another aspect of sustainability, which is reducing waste?
Okay, thank you, Abdel Latif. Geometallurgy is in the core of our duties. I think it's especially in our department as geosciences and strategic mining grow in terms of GSMI, I think, in UM6P. So just talking about the definition of geometallurgy, or what Mr. Mustafa like to name geomineralogy. It's wider than metallurgy, I think. So geometallurgy, it's the bridge between geology and mining and also processing. That's integrating the mineralogy, geochemistry, and mineralogy right from the exploration phases to be more efficient and sustainable in exploitation of our resource. So by analyzing mineralogy and also having the connection between, knowing the connections between mineral phases and also the speciation of valuable elements. Once we have that, we can predict how the ore can react to processing techniques and allow us to optimize extraction, guide us in the laboratory test works, and also build a more efficient flow sheet. A flow sheet that maximize the value of recovery and minimize the cost and also minimize the environmental impacts. So beyond extraction, geometallurgy or geomineralogy, it's a good tool for sustainability and resource efficiencies. So by characterizing the waste streams, we can define some kind of methods to evaluate or valorizing the byproducts and even recovery of the byproducts. So we have to say that geomineralogy also helps to lower or be optimistic in the energy and water and also reagents consumptions.
Okay. Thank you. So, Sema, so you are using the geometallurgy or geomineralogy in order to maximize your NPV, but while considering, I think, the sustainable aspect of your operation. And you talked about the environmental impact related to, especially, for example, reducing waste generation, or also by waste valorization. So, Dr. Talal, as a head of sustainability, do you have any strategy related to waste circularity in OCP operations?
Thank you, Abdel, for this question. It's very interesting because in my first answer, I focused mainly on decarbonization, while sustainability is, I would say, wider than just decarbonization aspects. And here there is, I would say, a couple of aspects. First of all is circular economy, and that's in line with your question. In the circular economy, we have three axes, basically. One, we have for the bioproducts, where we have close collaboration with our colleagues at UM6P from R&D perspective. The same thing for, I would say, waste. And waste, I would say, we have a couple of projects on the engineering part where it's actually, what is interesting, it's come from OCP employee, basically. So today I was really lucky to attend what we call Demo Day in movement at OCP, where different idea from different colleagues in different SBU, they bring their projects, they show it to the audience, and if it's interesting in the good case, so OCP Finance and go on one of those projects in the waste perspective. So it was starting from this initiative. So we are working, I would say, on R&D perspective, innovation perspective from our employee, because they have the experience, they know how to manage that waste, and also third axis, rehabilitation. Which is a very important part, especially, as I mentioned before, with the growth. So there is more space to rehabilitate. So we're looking on clear vision beyond 2030, how we do that. There is different typology of projects and so on. So briefly, not to go in the details, so we are working on those aspects of sustainability. It's not with low priority, it's the opposite, it's a high priority. So waste, byproducts, and rehabilitation. Another aspect is quite also important in sustainability is water. And as we know, in the Moroccan context, water is very important. So at OCP, there is very big projects on desalination to provide the mine, but there is an important dimension is the community in those projects. So in planification and study of the projects, we take into account this part. So we are not only feeding our sites, but also all the cities around. And there is another aspect of it is agriculture, which is important. So this is why I want to emphasize on the sustainability aspects. It's not only for OCP, but it's a wider perspective for the society itself. So yeah, and of course there is more that we are working on the ESG. So mainly today I speak about the E, but there is the social aspects and the governance and then the sustainability.
Thank you. So what to retain is there is a lot of initiatives and solution to make the mining operation more sustainable and more resilient. And it's the same, I think, is the same ambition from geoscience perspective, but also from the university perspective. From what I heard from the presentation of Richard is there is a huge gap between the trained people offered by universities and engineer schools, and what is really needed by the industry. So I want just to hear your opinion about that. Why do we have this gap between industry and academia? Richard, yeah.
So I think, speaking from an Australian perspective, I actually think from what I've seen here in UM6P that the gap is probably not as large because there's much more engagement directly with industry. From an Australian perspective, I think some of the universities are quite traditional with a staff of mainly academic geoscientists who have limited links to industry. To sustain an academic career in Australia, you must be publishing papers constantly, and it doesn't give many of the staff an opportunity to actually experience industry. So many of the academics have no. So I think there is a bit of a disconnect there. And potentially, I think as well in the past, some of the research projects in Australia have Thank you. Maybe it needs a new lithium battery. We should mine some more lithium. But yeah, I think there's some disconnect in Australia. It's there are universities that have funding from minerals industry, but it's hot and cold some years, not other years. I haven't seen the model from this university where it's sustained and very forward-looking. So I think in a way, in many ways, what I'm seeing here in Morocco is better than what we're seeing in Australia. I'm not sure if that answers the question, but I think Australia could learn a lot from this.
Thank you. So maybe I want just to hear the opinion of Malcolm and Tawfiq. So during all this session, this mining session, everyone was talking about automation, AI, robotics as well. So what do you think about the ethical consideration that we must consider regarding job replacement? And it was, I think, a question that was asked before.
Can you repeat the question?
During this mining session, we were talking about automation, like automating mining operation, extraction, and everything, hopefully. So what are the ethical considerations related to job replacement?
So, yeah, automation. So if I understand well, it's more about what kind of aspect or challenges on top of the automation.
Mm-hmm.
Yeah. So automation is, just to give you, I came across a report when I was doing some work last year for the US Department of Energy from what they call it the bipartisan policy group. and they were addressing this aspect for in the US. But at least in the US. It's really interesting. I mean, it's 2024, from 2024. And they looked at the automation, they looked at different aspects, and they found out that there is something in common between nickel, rare earth elements, graphite, and by the way, we were talking about graphite yesterday evening, and this is, it's more about the expertise to address the automation, labor expertise. We'll join and we'll go again about what was mentioned for the AI, for the automation, for the digital twin. And this is really one of the biggest challenges that one mentioned in this report. It's surprising because I was expecting something like energy, I was expecting something, but it was mainly the labor expertise and the lack of, it's more, by the way, it's more than scarcity or availability of the feedstock. So this is in short, in really in 2 words, that was really the issue that was highlighted in this report. Fortunately for Morocco, and I'm sorry, I apologize for my colleagues from the OCP, I don't have a lot of knowledge in this. I left Morocco 30 years ago. So, but at least for the US, I can tell you that this is one of the biggest challenges.
Thank you. So, dear Malcolm, what do you think about like particular consideration of job displacement in mining sector if one day we are going to implement the mining 5.0?
Certainly. As I mentioned during my presentation, the mining industry, as many industries are doing, are going down the path of utilising robotics to be able to improve the mining process. And as per the question from the crowd, unfortunately, there are some jobs we will lose through that process. But on the flip side, many of those jobs are extremely boring. Some of them extremely high risk. Sitting in a truck driving up and down a hill 12 hours a day is not my idea of fun. And certainly some of the images that Richard showed, the older mining where people were in some very risky scenarios and many didn't come home. So robotics has an opportunity there to address some of those business risks. But on the flip side, this new technology, the robots themselves, all the ecosphere around them requires a whole new skill set. So all of us here are pretty well grey hairs. Many of as we grew up, we knew nothing about data science. There's a whole new sphere there. One of the new technologies we are going to put in, autonomous drills. One of the big issues I've had with that over the years is we take the operator out of the cab, but that operator did 7 other jobs. Now that operator's not there, who's going to do those 7 jobs? So that's 7 robots I need built. So far someone's managed to build me 1. So it creates all these new opportunities to create new skills, to create new technologies and a whole new ecosphere that is going to drive a whole new issue for training. How are we going to train these people? How are we going to build our education system? As I build a new technology and roll it out, how do I get the education facilities around the world to be able to help provide the resource I need to invent that and maintain it?
Thank you. So I will finish with a question to Professor Mustafa. You talked during your previous answer about some development in some technologies regarding characterization, maybe also estimation. I want just to hear from you one practical project where you have like developed and worked very closely with OCP in changing something in the way of doing of today.
Thank you, Sir Abdel Latif. First, at JSMI and UM6P, we are trying to work with all mining company here in Morocco or even in Africa or elsewhere. And I think even OCP, who is behind UM6P, need us to be performant in terms of serving whole industry. At JSMI, we are trying to be involved in three manners. The first one is, as you said, tackling some problematics related to the mining sector in terms of R&D and even with innovation. So R&D and innovation. We are trying to train the future talent for this industry, and we are also trying to offer some specialized services to the industry, because sometimes the industry is not searching R&D project, but they are needing immediate answers to some problems related to exploration issues or processing or mining. So we are trying to work. So with OCP, we have good experience. At the beginning, it was not so easy because we had to know each other. We need to understand their needs, but also their constraints, because they are operating and they have some constraints. And I think even JSMI is a young entity, but we are now dealing with some very important strategic partnership with OCP, with some project that represent some KPI for OCP. And just to give you one example, we had this project related to mine waste, the management of mine waste. So OCP are still working in this linear, let's say, industrial pattern. But their needs, as explained, is to shift to more circular economy and to see how some waste, I prefer to call them byproducts, could be maybe could provide some added value for OCP. So one of the projects we had was the characterization after a sampling process that was not so easy of some mine waste spoils, and then define what could be the value within this mine waste spoils. And we developed reprocessing techniques that allowed using ore sorting, but other techniques downstream to valorize the residual phosphate. These byproducts still contain a lot of phosphate. And then we discover other possibilities of valorization, like limestones, dolomite for magnesium, and so on. So this is the idea, is to keep this collaboration and have this long-term project, because we can't believe that in 1 year or 2 years from the finishing a project, we can start with developing the practice. But we are more in long-term strategy for OCP to minimize the waste, to help in this rehabilitation objectives of OCP.
Thank you, Mustafa, and thank you all for this discussion. So what I retain, the key is the collaboration between industry and the university. We need to build a certain trust between both, and to, I think, fix some common objectives between the university from academia perspective and industrial operation challenges. So we need to make some trade-offs, I think, in the future. So I will just now invite the audience. If you have any question for our panelists, please, this is the time.
So first of all, thank you for the discussion. It was very interesting. I do have a question. So apart from the ethical consideration that I believe you already covered, I do want to ask, what are the main challenges or difficulties that you faced whilst trying to implement technology, specifically speaking of AI or machine learning models? And by this, I specifically mean, was it like a data acquisition problem, or was it, for example, expertise issue, or was it time constraints issues? And thank you.
Just from my perspective, excellent question. Thanks a lot, really. From my area of industry, I'll tell you, and I'm really sorry for my boss and the boss of my boss. The issue was to convince the management. Really, to convince the management, because that was really, and to find the real champion to go and take the right message to convince them. And I know a lot of companies are doing something which is boot camps right now. They're taking the managers and getting them really aware of the advanced or the added value that sometimes is not tangible to this AI, on top of the other challenges. But just one other aspect that is really important to take into account is you need your stakeholder, you need your management stakeholder. You need the big boss really to support your project. So it's really important when you implement this kind of project to involve them and to educate them and to get them really aware. And at the end, they will be the biggest supporter for you.
Maybe I can add the other challenge is to attract computer science maybe student or employees to work in applying AI for the geosciences and for the mining sector. As it has been said, maybe mining need to improve the reputation. And if I'm a software engineer, I don't know what is your background. Maybe you can present yourself. But are you interested in applying AI in the agri-food industry, or in the mining sector, or metallurgy, aeronautics, or so how we can have this software engineer working on the mining sector, in the mining sector?
Thank you, Sims. Maybe I will have a question for you, Ihsan, as you have a background in, I think, computer science and AI, and you decided to join, to doing a PhD in mining and geoscience. Why? What was your motivation to shift from I say computer science to mining and geoscience?
I guess my main reason why I wanted to join that is I already had experience before with applying artificial intelligence into environment problematics. I worked in 2 internships, both related to energy and both related to water desalination. And I had the opportunity to apply AI to both these fields. And I think that was my reason why I wanted to continue in that in that road. I wanted to not only study AI just to study AI, but I wanted to study AI so I can actually see where we can apply it to sort of make an impact in the one of the most important fields, which is environment. So that's it.
Thank you so much. Do we have any other question? We have one question behind you.
Thank you so much for the opportunity. The question I want to ask is related to career. For instance, most of the conversation we've been having today has boiled around sustainability. And for us to really engender sustainability in companies, we need people, maybe chief sustainability officers or people who are in charge of making sure that everybody's aligned on the plan on sustainability. So for someone with a social science background, not from a STEM background, and is interested in working probably as a sustainability officer in a company, what's the best path to take to achieve this goal? Thank you.
Maybe Talal.
It's a very interesting and good question. So as I said, the sustainability in a traditional way, we focus more on the engineering side, on the metrics, on the technology. However, I would say the social aspect is very, very important. And as all the speakers here mentioned, the human aspect is one of the key drivers for sustainability. And by definition, sustainability is thinking about growth without compromising people and the environment. So no question about how important the social aspect here. And then I can go a bit beyond that. So social aspect is very important in terms of looking on the human rights, workforce, career planning, education, all those questions are sustainability actually. And thankfully, all the regulation coming in is pushing on that side actually. So we need to disclose all the data about our employee training, about, as you said, gender equality, about diversity. And here when I say diversity, it's not only female, male, but different type of diversity, ethnicity, even cognitive diversity. So sustainability, it's way wider than the traditional way of looking at it in terms of technology and engineering, and we need to reduce our CO2 emission and so on. We can't achieve all that without the human, I would say, element in the equation. So it's very important. As a social science, it can contribute very much to sustainability. Yeah, that's I can say.
Cool. I'll add into that, and what I think it's a great question because what you're identifying is a gap in the market. There's, we don't do that much now. In terms of a practical approach, how do you actually start to build that network to get the contacts to actually get a job or build your own job, which is the best way to do these things if you can. If you can engage with people from mining companies, get small opportunities, even just familiarizing yourself with mining operations, build a network of people who are working in that, and if possible, if vacation programs or maybe a short-term job. I say to my students in Australia all the time, sometimes you get these little opportunities, like maybe a part-time job working for a company, doing something a bit related. These are all skills that you're building up your experience, and after an amount of time, suddenly you find those skills have amassed into something that can help you sort of get through that door, and often just getting that first step can be difficult, but if you really want to do it and you keep trying, then it will happen. So, yeah, I think you've identified, a gap in the market there.
Maybe I can add just one comment. When installed here in Morocco, and I visit some mine here in UM6P, I was surprised to see that in the operation there is no environment coordinator, for example. There is no tailings facility coordinator, which in Canada you have maybe a team of coordinators that are only working for this sustainability. I think sustainability is now, for OCP, is now very well known at the corporate level, at the level of the SBU, but now we have to maybe make it operational at the level of in the field, maybe. So.
Thank you. We have a question here, please.
Already? It's already on the field. We have some coordinators, yes, in ESG, and but maybe it's dependent on which site you have visit. Techniques, okay.
The question, please.
Hi. In the first, I'm happy to for being here, and my question is the Moroccan strategy working to introduce nuclear energy into its program, or is it integrated? Are there job opportunities for those waiting to engage in this field in Morocco? Because I like this failure. Thank you.
Maybe Tawfiq, maybe? Maybe Tawfiq, if your opinion about...
I think I can answer briefly because it's the Moroccan context, so I know a little bit, not that much. So for the nuclear aspect, the good thing in Morocco, as we mentioned before, is we have a lot of solar and wind. So we have big opportunities to produce green energy without having thinking about nuclear. So that's, I would say, the overall strategy. And there is many targets, like in Morocco, by 2030, we need to have 50% or more than 50% is renewable. Now we're about the share of 30 and so on. So the strategy in the national level, it's more on the green or renewable energy for that. Yeah.
I will just extend and beyond Morocco and
sorry, Tawfiq, but it's a very good question. So for your age, so it's
excellent. No, I agree. It's really excellent one. I'll just give you another context and just compare 3 countries in Europe, just to tell you it's not as easy, and that's why the question is really interesting. You compare Spain with France, with Germany, and you had their neighbors, and they have the same challenges. But you see that the approach they are having to nuclear energy is not the same. So it's a tricky question. It's a tough one. And it's really worth thinking a little bit more about that. When you see from the French side, what they see, they valorize the economic aspect because it's the cheapest electricity. When you go to Spain, because of political reasons, they prefer to have green hydrogen. On Germany, because they're scared of nuclear. So there is still a lot to be done. And this is really the I think, opportunity also for the new generation, is to try really to look and to innovate and to think more about this one, and to make sure that all the unknowns are known, are removed. So this kind of energy, at least we know from, is it something we can use, in which context, is it really safe as they say, or is it really risky? So there is still a lot of debates, which is great, because for scientists, that's opportunity. Also for the coming generation, it's opportunity to think and to propose different things and to test and innovate.
Yep.
Hello. Thank you, Saad Latif. Thank you for the panelists. My name is Hamza. I am a PhD student at Geology and Sustainable Mining Institute. So you have mentioned the importance of advanced technologies for the future of mining projects. The integration of these advanced technologies, I am talking particularly about robots. I think it requires huge investments from mining companies. And given the fluctuations or the volatility of commodity prices, So do you think that mining companies are ready to make such investments in terms of people, in terms of softwares, in terms of infrastructures, particularly for mining companies with, which are exploiting deposits with medium to or short term in terms of life of mine? Because I think in such cases the return on investment may not be certain. Thank you.
No, very good question. Certainly, if you look around the world, there are only a very small number of companies that are putting in the big systems we are. They are extremely expensive, and as you say, they require a very long mine life to make them economic. We see a lot of mining companies in that tier 2 sector, in the junior sector, that are still using robots. You can go down to the supermarket just about these days and buy a DJI drone and you can get video footage. So we see a lot of organisations are starting to do that. As it's starting to become pervasive here through Morocco. Through the rest of the world, we find that the telecommunication companies are implementing 4G and 5G networks. So now a lot of mining companies just use their mobile phones for communication. So through all these different technologies, there are a lot of cheaper robots out there instead of the nice big white truck I showed, that these other companies can utilise and get absolute value from. So I'm probably one of the people around the world that also, how do we make these big robots more applicable to the juniors? If I can sit up there on the lectern there and say what this technology does in terms of safety, what it does in terms of preventing people dying and having injuries, what it does in terms of the economic value to the big mines, then how do we challenge that? And if you look at some of the papers, do some research particularly in China and a few other places around the world that are coming up with alternative technologies. So instead of going to the big American Caterpillar and spending a very large sum of money to buy from there, maybe you can go to AECON out of Beijing and buy a very similar truck for a lot cheaper prices. So back to that challenge. Who can come up with a cheaper, better robot to do the same task?
Thank you. Maybe we'll have like the time for a last quick question. So, Hannah?
Hi everyone. Thanks for your thanks for your insightful speech. And my question is addressing a very challenge talking water. We know that we are aware about this that water is like a challenging topic for Morocco and for OCP as well. And we know that water is really used in our processing. So the OCP's processing requires many metric cubic of water. My question is regarding the technologies to include in our future mine. And here I address my question especially to Malcolm regarding the mining 5.0. Is there any technologies that will consume less water or at least use like a circular economy so we can reduce or we can manage as much as we can this resource? Thank you so much.
No problems. A good question. I've been on a number of water conservation projects around the world, and a lot starts at the beginning of our understanding of the ore body. Do we understand the geology well enough to be able to know that we are extracting it the most efficient way and processing it the most efficient way? Are we identifying the best reagents to be able to conserve that water? Are we treating our tails sufficiently instead of having a high water feed from our plant to our tails dam and letting it evaporate? Are we putting in some thickeners and even high pressure grinding, or sorry, not high pressure grinding, high pressure water recovery to be able to pull water out and send it out as a paste? So there are absolutely a huge number of advantages there. So some other projects I've worked on, OCP's got pipelines. where we send product down to the chemical plants. In other places around the world that I've worked on, they put a second pipeline in and pump the water back to the mine. So once they've processed it, they have return water. So there are certainly things we can look at there through our processes.
Well, thank you. So, dear panelists, I want just to thank you for your availability, for sharing your insights, your experience with us today in this very rich session about mining, which is an important topic, which is the fuel of the industry of today. So please just join me to applaud our panelists. Thank you so much.
And thank you, Sir Abdel Latif, for the organization of this great event. Thank you very much.